But in between, if any participant finds that they need more examples or explanation, they can just drop in a message in the chat. And I think at the end of the lecture, for 15 minutes probably, we can 10 to 15 minutes, we can discuss those doubts or more explanation, whatever is required. Another thing, I would request all participants to kindly mute their mic so that there is no disturbance in between for other participants. Okay. So, Jitendra, shall I start?
Yes, ma'am. Yes, ma'am. You can continue.
Okay. Okay. So as you can see, the title of this talk is, as in the line of the workshop, Data Science and Analytics. So what I'm going to discuss today is mathematics in data science, but the other side of the story that you heard from Anuradha ma'am yesterday. So yesterday we had already two wonderful talks by Dr. Tapan and Dr. Anuradha. So they talked about some applications of data science, Tapan sir already, and Anuradha ma'am talked more about mathematics in data science from the perspective of statistics and probability. I will take you today on the other perspective, that is linear algebra, which is very important part of computer science, data science everywhere. So we'll talk about some basic concepts of linear algebra and their implementation. Okay. So what is it all about, data science? Already you saw yesterday. So for instance, what topics we are going to see today, what does they relate to? So for instance, when you take a digital photo with your phone or transform the image in Photoshop, we usually do, we have to reduce the size, or we have to make it more bright or whatever. When you play a video game or watch a movie with digital effects, when you do a web search or make a phone call, so we all are using technologies that are built upon linear algebra. We'll see shortly. So linear algebra basically provides concepts that are crucial to many areas of computer science, including but not limited to graphics, image processing, cryptography, machine learning, computer vision, optimization, graph, algorithms, web search, so on. Now, linear algebra in turn is built on two basic elements, the matrix and the vector. So we are going to talk about, first of all, about, most of you know what is a matrix, what is a vector, but I need to relate them to the coming up applications that I'm going to discuss. Another thing is that linear algebra is basically the study of the notion of linearity, how two things are related to each other. So linearity, which arises mainly from two sources: study of system of linear equations. So this is the first thing. So this is a brief outline of the talk. So study of system of linear equations. Okay. And in that we'll see some basic definitions, rank of a matrix, applications. So we'll be concentrating more on this first part. And second, which we are not going to talk much, is study of geometry in the algebraic setup. So we'll be concentrating on the first one, that is the solution of system of equations. And then we are going to talk about a very important concept in linear algebra, that is eigenvalue problems, which uses eigenvalues and eigenvectors. So we'll be going around with the definition, some geometric interpretation, then some computational steps to find eigenvalues, eigenvectors, and some applications. And at the end, if time permits, then I would also like to discuss singular value decomposition, which is a very, very important part of linear algebra, having applications, tremendous applications in computer science. So I think I will just switch off my video for better bandwidth. So let us start with the first section. So here are some preliminaries, and I apologize to participants who already know this, but I'm sure it will be useful for people who have forgotten these basics. Okay, so we consider a system of m equations in n unknowns. So first equation, a11 x1 plus a12 x2 plus so on plus a1n xn equal to b1. a21 x1 plus a22 x2 plus so on plus a2n xn equal to b2, and so on. First equation, second equation, and the mth equation is am1 x1 plus am2 x2 plus so on plus amn xn equal to bn. So this is m equations in the n variables, n unknowns, x1, x2 up to xn. So we can write this system of linear equations in a matrix form as Ax equal to B, where A is the coefficient matrix, all these constants, Aij. So A is the coefficient matrix, M cross N coefficient matrix. X is nothing but the vector of this unknowns, that is x1, x2 up to xn, and B is the right hand side vector, which is also given to us in the system. Okay, so in this system, Aij's will be given to us, B1, B2 up to Bm will be given to us, and we would need to find x1, x2 up to xn. Okay. Now for a simpler system of equations, let's say 2 equations in 2 variables or even 3 equations in 3 variables, it is not that hard to compute it by hand. Okay. Also, we can use Cramer's rule. You might have heard about it. But let's say when the system becomes more complicated or bigger and bigger, 10 cross 10, 100 cross 100. So are we really going to solve it by hand? Answer is no. So what are we going to do is we are going to apply some more techniques. So let us start with that. So first of all, one notation. So the A, which was the coefficient matrix, will just augment it. Augment means we will add another column to this matrix, which is nothing but B1, B2 up to Bn. So we'll place the vector B, the column vector B, on the rightmost of the matrix A. That will give us matrix of this form. So this new matrix, augmented matrix, will denoted by A mod B, is a M cross N plus 1 matrix because now it has M rows and N plus 1 columns. Okay. Now what are we going to do with this augment matrix? As also in the outline of the talk, we are going to learn about rank of a matrix. Because rank of a matrix is going to help us not only in solving the system of equations, but later also. So we will need 2-3 definitions first to go to the rank of a matrix. For now, we just need to remember that we have this system of equations and this is the corresponding augmented matrix. Okay. Now given vectors x1 up to xn and scalars, some aij's or a1 up to an or alpha 1 up to alpha n. If we take the linear combination a alpha 1 x1 plus so on alpha n xn, it is called a linear combination of the vectors x1 up to xn. The vectors xi are said to be linearly dependent if and only if at least one of them is a linear combination of the others. Okay, that is, let's say x1 is equal to alpha 2 times x2 plus so on plus alpha n times xn. Otherwise, they are called linearly independent. Another equivalent way of saying this is mathematically that this linear combination alpha 1 x1 plus up to alpha n xn equal to 0 would imply each of the alphas are 0. Then it is linearly independent. If at least one of the alpha is non-zero, then they are linearly dependent. Okay. Now I come to rank definition, the maximum number of linearly independent rows of a matrix A. Why are we studying rank? We are studying rank so that given this system of linear equations, which we have transformed into a matrix form, we can simplify that matrix and find the rank of that matrix, and this will give us a simplified system of equations, which will be very easy to solve as compared to the original system of equations. So here is the procedure. Step 1, given system of equations. Step 2, write what is the coefficient matrix. Step 3, write what is the augmented matrix. Step 4, find the rank of the matrix A, then the rank of the augmented matrix A mod B, and then that will give us step 5, a simpler system of solutions which is easily solvable. Okay. So rank is the maximum number of linearly independent rows of a matrix A, will denoted by rank of A. Now we are going to use this property. So I just listed 5 steps. So what is crucial in the 5th step? Why we are getting a simplified system of equations? Because row equivalent matrices have same rank. I'm not going to go into any of the proofs or details, anything. Just take it as facts. So we'll simplify the given coefficient matrix So now we are in step 3. I said step 1, you have a given system of equations. Step 2, you write A. Now we can apply following elementary row operations. That is, we can interchange the order of 2 rows. I'm just going to come to an example, okay? So just be with me. So we can interchange the order of 2 rows, or we can multiply a row by a non-zero constant, or we can add a constant multiple of one row to another row. None of these is going to change the rank of the matrix. Why? These 3 operations is nothing but operations on the equations itself. Okay, so let's say I have equation x plus y equal to 2 and x plus 3y equal to 3. So it doesn't matter if I have, maybe let me go to, okay, so for example, this, we are going to come to this. So in this example, if I interchange the first 2 rows, so what is this corresponding to? This is corresponding to x plus 3y. This is the augmented matrix. X plus 3y plus 3z equal to 2. Second is 2x plus 6y plus 9z equal to 7. And yes, there is example. So that's why I have opened this example. And third equation corresponds to minus x minus 3y plus 3z equal to 4. So this is already, we are in step 3. So in this example. So step 1 was the 3 equations that I just told you. Then step 2 was to write A, and this is step 3, the augmented matrix. Now we can apply elementary row transformation. So what have been applied? So what is the rule for this? So we'll consider the first non-zero element, the leftmost. Here it is non-zero, we'll keep it as it is. Now we'll try to make the elements below this 0. Okay. Why we are making it 0? Because that would give more coefficients in the new system as 0. So row 2 will change row 2 to row 2 minus 2 times row 1. Okay. So which operation is this? This is the third one. Multiplying a row with non-zero scalar and adding to another row. So R2 minus 2 times R1 will give me 2 minus 2, 6 minus 6, 9 minus 6 equal to 3, 7 minus 4 equal to 3. Similarly, I have to make this as 0. So this, what we can do using row 1, that is our basic fixed row. So what we'll do, R3, row 3 goes to R3 plus R1. So minus 1 plus 1 will give me 0, minus 3 plus 3 will give me 0, 3 plus 3 will give me 6, and 4 plus 2 will give me 6. So this is my first iteration, I could say. Okay. But still, it can be still simplified. How? We can see the second and the third row are multiples of each other. So what we can do, we can apply once more, row 3 goes to row 3 minus 2 times row 2. First row will be as it is, second row will be as it is, and third row is R3 minus 2 times R2. So that will give me 0 minus 0 is 0, 0 minus 0, 6 minus 6 is 0, 6 minus 6 is 0. Such kind of a form where we have non-zero element at the start, these are called pivots. We could have also had here 2, for instance. And below those elements, we'll have all zeros. How it is going to help us? So now if I change it back to the system of equations, what this matrix will be? So this is my augmented matrix. So that means this quantity 133,003,000 times xyz is equal to 230. So last equation is anyway 0. The second equation will give me 3x3 equal to 3. That is x3 equal to 1. Putting it in equation 1, I can get the values of x1 and x2. Okay. I can further simplify this echelon form by making these, wherever simplifying this to 1. So I will divide the row 2 by 1, and this will be called a reduced row echelon form. We'll see more examples. Okay. So this is the procedure that given a system of step 1, given a system of equations, step 1 is to write the coefficient matrix A, which is this one, 1, 3, 3, 2, 6, 9, minus 1, minus 3, 3. Step 2, write the augmented matrix. Step 3, apply the elementary row transformations. Get the reduced row echelon form. Once we have the reduced row echelon form, we have just seen the definition of rank. Rank is the maximum number of linearly independent rows. Now, linearly independent, we have just done the definition that one cannot be written as a scalar multiple of the as a linear combinations of the others. So in this case, rank of A is 2 because there is 1 0 row, non-zero rows I said, maximum number of linearly independent rows, and 0 is linearly dependent. And rank of augmented matrix is also 2. So in this case, we are having rank of A and augmented matrix both to be same. So I'm going back to the algorithm now. So for a given n cross n matrix, if rank of A and A augmented matrix is both are equal to n, I'm talking about square matrix, then the system has unique solution. If the ranks are equal but less than n, which is the case in our example, so ranks are equal to 2 but less than 3, then equation has infinite number of solutions. So what are the infinite number of solutions here? Z is equal to 1, but when we don't have to put Z here, it is x plus 3y equal to minus 1. So if I put any value of x, let me put it to be 1, then accordingly I will get 3x2 equal to minus 1, that is x equal to minus 2 by 3 and so on. So it will be an infinite system of solutions. x1 plus 3x2 equal to minus 1. Okay, and if both ranks are not equal, then the system has no solution. So we see how, given a system of equations, just by taking the coefficient matrix, simplifying it using elementary row transformation, finding the rank of the simplified matrix, we can just figure it out whether that system has a unique solution or infinite solution, infinite number of solutions or no solution. And this can also be done very well using computer, because for let's say 100 cross 100 matrix, how we can do that? So MATLAB, Mathematica and all we can use. Okay, so I hope this rank is clear and example. So I'm in the next slide, I'm going to come to one application in which I will we'll see another matrix, and we'll again do this elementary row transformations and see the rank constraints. Okay, so if there is no doubt, then let me go to another example in the line of application. Okay, so first application of system of linear equations. So consider a traffic flow. So okay, so at any point, so in Nagpur, in Delhi, Pune, wherever. So at any traffic signal, so there is a crossing of many streets. So let's say we have considered a standard network of 4 one-way streets. One-way means, so okay, so this is point A. One-way means the arrows wherever it is represented. Okay, so let's say it's Delhi, because there it's one-way streets. So for instance, at point B, cars from this direction are, or cars or vehicles, 280 vehicles per hour. Then from D, this side, 236 vehicles per hour. So at this intersection point, we'll total have 280 plus 236 vehicles per hour. And then they are going to move in the directions Y and Z. But how do we know how they move? For that, we have traffic signals. And how the traffic signals are monitored? So let us see, because this is going to happen at each of the crossings. And the person managing the traffic signal have to make sure to send as many vehicles here on this road, on this Asafo Market road, or on the path Z, such that there is no blockage. There is no blockage of vehicles here at this point, because only 230 can go here and 110 can go here. So the maximum on this Z, 340 vehicles can come. That means remaining should go here. We have to see. We have to optimize. So this is what the traffic signal is been doing. So let us see how we can convert this network of one-way streets into a matrix. Okay. There are two assumptions for smooth flow of the traffic. First, I already discussed that vehicles entering each intersection, that is whether it is A or D or C or D. So from B, vehicles are entering From A, vehicles are leaving. From B, vehicles are entering. From C, vehicles are leaving. So vehicles entering at each intersection should be equal to the vehicles leaving the intersection. That is, traffic in is equal to traffic out at each of the points. So let's say at the point D, what will happen? 280 plus 236 is equal to Y plus Z. So X, Y, Z, W denotes the number of vehicles per hour on this road, connecting D and A, connecting A and B respectively. Second assumption is the streets must be all one way with arrows indicating the direction of the traffic flow, because otherwise we will not be able to manage how many vehicles are going and how many vehicles are coming back. Of course, that kind of problem is also handleable. Okay, but that is more complicated and that would need more concepts. So let us discuss this simplified version. Okay, so the mathematical model of this traffic flow system can be written or can be formulated as, so for D we already talked, Y plus Z equal to 516. Okay, now let's say at A, 190 plus 241, that is 431 is equal to X plus Y, that is at A. Similarly at B, so X plus W, the vehicles going out is equal to vehicles coming in, that is 105 plus 150, that is 255. Then at point C, Z plus W, vehicles going out are 230 plus 110, that is 340. So this network has been transformed to this system of linear equations. X plus Y plus 0Z plus 0W equal to 431. X plus 0Y plus 0Z plus W equal to 255. 0 times X plus 0 times Y plus Z plus W equal to 340. And 0 times X plus Y plus Z plus 0 times W equal to 560. Okay, so now we will write, so this was given system of equations. Again, back to the steps that we have talked about. Step 1, write it in matrix form. X plus Y equal to 413 and so on. Step 2, write the augmented matrix. So we just wrote A and placed B on the rightmost. Then we apply the elementary row transformations that we have discussed. So we'll first of all make this as 0. So R2 minus R1, that will give us minus 1 here. So then I think we have multiplied by minus 1 and so on proceeding. So will be finally simplified to this matrix. Now again we see that there is a 0 row coming. Okay, that means rank of A is equal to 3 is equal to rank of the augmented matrix, but not equal to n. So more than one solution exists. So let us rewrite this simplified augmented matrix back in terms of a simplified system of equations. First one will give us X plus W equal to 255 or X equal to minus W plus 255. Second one will give us Y minus W equal to 176. That is Y equal to W plus 176. Third one will give us Z equal to minus W plus 340. So there are infinitely many solutions, because if I put any value of W, I can put 100, 200. So whatever is possible, we'll just talk about it. And then accordingly, we'll get the values of X, Y, and Z. And that will determine a different traffic flow. So let's say we prefer minimum value of Z. Why we prefer minimum value of Z? Because that was the junction which was heavily crowded. Because here also too many vehicles are passing, 516. And here also only 340 are going out. So we really have to take care of this junction. So let's say we prefer minimum value of Z. So for minimum value of Z, the largest value of W will be 340. But we also want X and Y to be positive, because number of vehicles per hour cannot be negative. So for X and Y to be non-negative, largest value of W can be 255. So for this equation, largest value can be 340. For these two equations, largest value can be 255. So let us take smallest value of W, which will be the difference of the two, that is 85. So to keep the traffic flowing, we can take any value which is around 85, 90, 95. So let us take W equal to 100. This is one set of solution, one possible traffic flow. Then we'll get X equal to 155, Y equal to 276, Z equal to 240. I hope the augmented matrix and rank and those constraints are more clear now. Okay. Any doubt? Okay. So this way we have found one possible traffic flow. Similarly, for different values of W, we'll find different values of X, Y, and Z. Okay, now I come to a second example, which we will not talk too much in detail because we have already learned. So basically, if we have a network model, right, electrical network, for instance, this one, and we have to use system of equations to find the currents, I1, I2, I3. So using Kirchhoff's current law and Kirchhoff's voltage law, what we can do at the left hand side or the right hand side node. So what does it say? The total current flowing should be the current coming in should be equal to the current going out. So let's say at this junction. So I1 is coming in, I2 is going out, and I3 is coming in. So inflow of current is I1 plus I3, and outflow of current is I2. So I1 plus I3 should be equal to I2, or I1 minus I2 plus I3 equal to 0. Same will be at this right hand side node. Another thing is Kirchhoff's voltage law. So that says the voltage across the loop. Okay, so if we consider the top loop, 3 times I1 plus 4 times I2. So we are considering it in anti-clockwise direction. Okay, so 3I1 plus 4I2 equal to the voltage 3. Similarly, in the bottom loop, 4I2 plus 2I3 equal to 2. So what are we having now? So we have transformed this electrical network to a system of 3 equations in 3 variables, and we know how to solve them. Okay, so I will not go into details of solving them. It is an application. Is this fine? Then I'll go further. Okay, perfect. So let us take another example of system of. So throughout the talk, this system of linear equations is what is going to be used throughout. So one more. So we have just seen traffic flow, electrical network. So let us see cryptography. So let's say for encryption and decryption, we have some message, secret message or some secret information, and we need to encrypt or decrypt it. Okay, so encode or decode. That is also that are also the. So for those, because it's a secret information, we would need a key to encode or decode it. So for instance, I have taken a very simple example. So UTES. So let's say I have a message UTES and I want to send it to someone so that it is not leaked in between. So what I am going to do, I will assign a numerical value to each letter in the message. What are the letters? U, first letter U, second letter T, third letter E, and fourth letter S. So once assigning numerical value to each of these letters, we'll get 20, 19, and 418. So just let's stop for a minute and you think about it. It's very easy. So how we have got this? So that means, so I have purposefully taken it into column form. You can also write it as 20, 19, 4, 18. And then we'll divide it as matrix form. So U is corresponding to 20, T is corresponding to 19, E is corresponding to 4, and S is corresponding to 18. Okay, so Hanumantrao Bitra. Yeah, perfect. Okay. So assigning the number to a letter. So in practice, the letters can be assigned any value. So I can make my own coding, right? It's my wish. So instead, so here we, for simplicity, we have assigned.
Yes, ma'am.
May I request all the participants to mute their mic?
Yes.
May I request all the participants to mute your mic?
No, ma'am. Dot, he was telling absent, I'll write absent. I've given dots. He told to write absent. He told to write absent. So I'll do it.
It is difficult for me to
This
concentrate
is
this
done, ma'am.
way.
It's okay. All the students are there. But how the student list, they will have the wrong spelling? They have changed the
Can please use
spelling.
them
Jai should remove
manually.
it totally. It's Abhishek Vishwakarma. Intentionally he has done it.
Mentor is Sharana sir and you.
No, not me. I'm class teacher. Saroraj. I've got the third sem now, ma'am. Already I've got 32 students in the third sem. I let it be like that. Don't change it because already we are in good touch. What is the sound?
Sir, can you kindly mute your mic, please? We are getting disturbed. Okay, at least for now there is no noise. Okay, so let us come back to it. Okay, so in practice, so we have learned alphabets from childhood: A, B, C, D, E, F, G, H up to Z. So how many alphabets? 26. The easiest way is A equal to 1, B equal to 2, Z equal to 26. But this will be of hardly of any use because anybody can decode it. Okay. So what we can do is we can, for instance, shift this order by 4 or 5. So for instance, I can start with 5. I can take A equal to 5, B equal to 6, C equal to 7, so on. Z will be 31. Okay. And so on. So I can take, this is one way, or some other random assigning I can do. Anyway, so for simplicity, let us just take this one. And the sender has to make sure that as long as the sender and recipient both know the corresponding values, one can assign any kind of values. So the codes can be so complicated, actually they are, that even these assigning these values would also need some decoding. Okay. Anyway, we'll just proceed with a simple this assignment. So we will encrypt this message UTES using the matrix K. So this is one example. So I will use this as the key. Okay. So my matrix is 20, 19, 4, 18. This will give me a 2 cross 2 matrix. So I have taken one of the most simplest example, 2 cross 2. It can be 4 cross 4, 10 cross 10, 100 cross 100, so on. So what I will do, I will multiply this matrix that I have got from the message. I will pre-multiply it by the matrix K, and that will give me this matrix which has larger values. We can also leave it as it is, but for one more, like another security step, that I know I am the sender and the recipient knows. Let us take it modulo 26. So modulo in mathematics means we'll take the multiple of 26, whatever comes here, and then remainder here is, okay, let me talk about 30. 34 is 1 times 26 plus 8. So if I divide 36 by 26, 34 by 26, the remainder will be 8. Similarly, 138, if I divide by 26, the remainder will be 8, and so on for 99 and 193. So pre-multiplying the matrix of my message, I am getting 21, 8, 11, 8, 8. Now, so one option is I will just send this matrix. Second is I will further change it into letters. So this 21 will correspond to V, 11 will correspond to L, and 8 corresponds to I in this assignment. So the original message that was UTES, it was just an example, is now encrypted to VLII using this assignment: A equal to 1, B equal to 2, so on, Z equal to 26, and the matrix K equal to 4137. Similarly can be done for a longer word, and then we will have a 3 cross 3 matrix. For instance, we will be having here, instead of 4, 9 alphabets. Then that would give me three such 20, 19, let's say 10, 4, 18, 8, 3, 6, 7. That will give me a 3 cross 3 matrix here. In that case, I will need a 3 cross 3 key. And similarly, the result, the encrypted message will again be a 9-letter word. Okay. Now to decrypt. So let's say I wanted to send the message UTES, but I have sent them VLIN. Now to decrypt it on the other end, at the recipient end, they would need a key And what will be that key? That key will be the inverse of the encoding matrix. So this was our encoding matrix. So we know matrix multiplication, right? Matrix multiplication Ka might not be equal to Ak because it is a very basic concept. Matrix multiplication is non-commutative. But since if K is an invertible matrix, then Ka equal to 21, 8, 11, 8 would imply A equal to K inverse times this matrix. So when the receiver will get this word VLII, they will use this assignment and they will change the V. So just go back. So we have come from this word to this word. Now let us go back from VLII to UTES. So the recipient will now change VLII to 21, 11, 8, 8 and then pre-multiply it by the key, that is K inverse. And that will further modulo 26 will give us A. And once the receiver has got A, what was A? 24, 19, 18. Then he will again use the assignment of these numerical values to the alphabets and go back to UT. You can write it down. It is a nice game to play. And also I think even for longer words or other things, many exercises are available. Okay. So I hope this is clear. So we have done 3 applications as of now: traffic flow, electrical network, and cryptography. So now I will move on to the second concept, eigenvalues and eigenvectors. So first of all, let us see some basic definitions, example, and some computation. So we'll consider a square matrix of order n and an eigenvalue or a characteristic vector of matrix A is a non-zero vector x such that Ax equal to lambda x. Here lambda is the eigenvalue of the matrix. Now note that this is nothing but rescaling. So we are just rescaling with the constant lambda, which is called eigenvalue. So let's say, for example, if a matrix A x by stretching or compressing the vector x, okay, not changing its direction. We can also talk about direction, but not here. Okay. So let's say the matrix A is here and it will compress or stretch the matrix, the vector x. Okay. The direction of x is the same, whatever it was earlier. What we are going to do, we are changing by pre-multiplying x by a matrix A. We are changing its, not changing its direction, but either we are stretching it. So for example, if lambda is -1, then it will become smaller. It will change to -x. If lambda is 2, then x will change to 2x. Then x will be an eigenvector. So first we'll find, given a matrix A, we'll write this eigenvalue problem, Ax equal to lambda x. First we would need to find non-zero, it can be 0. First we have to find the values of lambda, scalars. We'll see how we are going to find. Then for each value of those lambdas, we are going to find non-zero values of x. Clearly x equal to 0 is a solution of this and therefore not interested practically. Not of that much interest practically. So we'll be looking for non-zero solutions. Okay. So is this clear? So this is nothing but rescaling the matrix x, rescaling the vector x using the matrix A and not changing its direction. Okay. So here it's lambda x and here it's lambda. So this y, x and y, so capital X here is basically x comma y. It has 2 components. Let's say A is a 2 cross 2 matrix. So when we are talking about plane R square, then n equal to 2, it's a 2 cross 2 matrix. Okay. So this Ax equal to lambda x. So we are now going to learn how to find lambda and then non-zero x corresponding to lambda. So first of all, let us write Ax equal to lambda x in rewriting, where so we have just brought the lambda x to the left hand side. So it will be Ax minus lambda x equal to 0. This is a matrix multiplication by A. and this is a scalar multiplication. So what we can do is we can write here lambda times I times X, where I is an identity matrix. I hope you all know identity matrix is a square matrix, that is, let's say n cross n, with 1 on the diagonal elements and 0 everywhere else. So I is the identity matrix. So to get non-zero solutions of the system 3, so we need this matrix, the coefficient matrix, to be non-singular. That means its determinant has to be zero. We need it to be singular. That is, its determinant has to be 0. So now we come to the computational steps, which are going to help us throughout the slides now, because in every applications I'm going to talk about of eigenvalues. We are going to convert the given problem into an eigenvalue problem. Then we are going to find lambda, then non-zero x, and so on. So computational step. So we'll compute this determinant, which is called the characteristic polynomial of A, right? Once we have computed this determinant, because A is known, so it was a coefficient matrix, right? Of A is Aij, so we know A. I we know because it has only values 1 and 0. So what is the unknown in this equation? Lambda. And the order of this equation, or I would say the degree of this polynomial, A minus lambda I, will be equal to the order of the matrix A. So if A was a 2 cross 2 matrix, this will give us a quadratic equation. If A was a 3 cross 3 matrix, this will give us a cubic equation in lambda. Okay. So some coefficient times lambda square plus some coefficient times lambda plus some coefficient equal to 0. So on, cubic equation. So second step would be to find the roots of this polynomial equal to 0. So this polynomial is called characteristic polynomial, and this equation, so characteristic polynomial equal to 0, is called the characteristic equation. Now once we find the roots of this equation, number of roots will be again equal to the order of the matrix, because any equation of degree n will have n roots. They can be real, they can be complex, they can be repeated. Okay, another thing that I have not written here, but in case it is a complex eigenvalue, then it will appear in conjugate pairs. No audio? Okay, let me check. Okay, so I hope I am audible. Can anybody confirm, please? Okay, thank you, thank you. Okay, so once we have found the eigenvalues, lambda 1 up to lambda n, so I just said that if some of them are complex, then they need to appear in conjugate pairs. So what does that mean? So let's say lambda equal to alpha plus iota beta is an eigenvalue, then alpha minus iota beta will also be an eigenvalue of the same characteristic equation. I mean root of the same characteristic equation. So eigenvalue of the matrix A. Now for each eigenvalue, we need to solve the equation. So first of all, we have found the determinant, then wrote it as an equation, find the values of lambda. First thing is done. We have found out the eigenvalues. Now we are going to find out the eigenvectors. So for that, we will just pick up any eigenvalue. Let's say we pick up lambda 1. We have to go one by one. So for each eigenvalue, we will solve the equation. Let's say for lambda 1, A minus lambda 1 I equal to X. We know what is A. We also know what is lambda. We also know what is I. So this way we can find a non-zero value of the vector X. And that would be the eigenvector corresponding to that eigenvalue lambda 1. So the roots of the characteristic equations are eigenvalues, and the corresponding vectors that we get from this equation, corresponding non-zero vectors, will be the eigenvectors. Okay, so let us do one example. So we have, let's say again, a very easy 2 cross 2 matrix. So 4 minus 5, 2 minus 3. Okay, so I think it's better that you do this example with me. So just take a pen and paper and just try. So step 1. So we know A, find the determinant of A minus lambda I. So I is 1, 0, 0, 1. So that means on the diagonal entries we'll minus lambda. So 4 minus lambda minus 3 minus lambda. Determinant will be 4 minus lambda times minus 3 minus lambda, okay, minus 2 times minus 5. So when we simplify, we'll get lambda square minus lambda minus 2 equal to 0, and that will give us two values of lambda, that are lambda 1 equal to minus 1 and lambda 2 equal to 2. So this was the first step. So we have found lambda 1, lambda 2. Two eigenvalues because the order of the matrix was 2. Okay, so this, I hope you have done it. And now, second step. So second step was, after finding the eigenvalues, then we put it in this equation one by one and find the non-zero value of x. So let us start with lambda 1. So what will be a minus lambda 1 I? A is given, lambda 1 is minus 1. So a minus I basically, that will be a minus minus 1 times I. So it will be a plus I. So 4 minus 5, 2 minus 3 plus 1, 1, 0, 0. That will give us 5 minus 5, 2 minus 2x equal to 0. Now see how nice it is. It is again coming back to system of linear equations. So let's say the vector x is having two components, a1, a2, or we can call it x1, x2, or xy, doesn't matter. Xy confuses a bit, so better is x1, x2. And right hand side will also be 0, 0. So now multiplying first row by this matrix a1, a2, we know the matrix multiplication. It is 5a1 minus 5a2 equal to 0. Similarly, 2a1 minus 2a2 equal to 0. Both equations are redundant. They are multiple of each other. So both equations will give us a1 equal to a2. So let us, so the eigenvector is basically x equal to a1 comma a1. So for simplicity, we can choose a1 equal to 1. That will also give a2 equal to 1. So similarly, with the eigen value 2, we'll have the eigenvector 5, 2. So I will wait for a minute now so that you evaluate this vector. x2 equal to 5, 2. So anyone who is interested in computing it now. Maybe most of you already know how to compute it, but just as an exercise, so that we understand the next coming up things much better. Okay, I'm giving you 1 minute. Okay, and in the meanwhile, let me complete with this remark that if x is an eigenvector of A, then alpha x is also an eigenvector of A for the same eigenvalue. So if I have instead chosen A1 equal to 2 equal to A2, then my eigenvector corresponding to lambda 1 equal to minus 1 would have been 2 comma 2. Similarly, k comma k. And here it will be 5 comma 2 or 10 comma 4 or 5k comma 2k. Okay. So just try with the second eigenvector. Okay, so one of the participants got it, maybe one or two more. Because in the next slides, we are going to do this again and again. would have our Mr. So, maybe let us finish with the eigenvalues and eigenvectors, and then if in case time is there, which I am sure there will not be, because we are also going to talk about some other applications. So, or at the end of the talk, I can explain for 5 or 10 minutes if you really want to. Okay, anyway, let us now, we are done with the example. Okay, so these are our two vectors. So this is what we have got. X1 equal to 1, 1 and X2 equal to 5, 2. Right? So from these vectors, we can see from the origin. So these are the directions. So X1 is, so what is this point? 1, 1. 1 on the x-axis, 1 on the y-axis. Similarly, this is 5 on the x-axis and 2 on the y-axis. Now, pre-multiplying X1 by A, what we are getting? We are getting minus 1 comma, okay, it is not here. So we can multiply it. So you can try. So you know the matrix A, if you pre-multiply that by x1 by A, we'll get minus 1 comma 1. So we have actually rescaled the vector x1 in the opposite direction. It is minus 1 comma minus 1. Although the direction is, so what we have said, we will just rescale it and not change the direction. So direction is still same, but in the negative quantity. Similarly, for this x2, when we pre-multiply it by A, it is in the same direction, but it just goes on. So it will be the point 10 on the x-axis and 4 on the y-axis. Okay, anyway, so this was about the vectors x1 and x2 that we have just found, the two eigenvectors corresponding to the eigenvalue lambda 1 and lambda 2. Okay, am I not audible? Somebody is saying I'm not audible.
Audible, ma'am.
Audible, ma'am.
Okay, thank you. Okay, so now if we want to take some other vector, any vector, okay, so remember 2 slides before we have talked about linear combination. So any vector that can be written as alpha times, let's say x1 plus beta times x2. So image of any vector x under A. So we have now got two vectors x1 and x2, and let us see if we can write image of any vector x under A. If x1, x2 are linearly independent, we can check the linear independence. That is not a big thing. Now we have considered any arbitrary vector, let's say minus 2 comma 1. Then that will be equal to 3 times 1 1 minus 1 times 5 2 equal to 3 x1 minus x2, right? So this minus 2 can be written as 3 minus 5 and 1 can be written as 3 minus 2. So x is 3x1 minus x2. So let us apply A, pre-multiply x by A, and same will go on to 3ax1 minus ax2. And we know what is ax1, what is ax2. We'll just write it down and we'll get the image of x under A is minus 13,7. Okay. So this just means that using these two linearly independent vectors x1 and x2, we have written the image of any vector x under A after writing the linear combination of x1 and x2. Okay. So this was about an example and some directions about these eigenvectors. Now let us talk about first application. I'm going to talk about 3 applications. The first one is first order linear homogeneous differential equation. So in many fields or situations, we are reduced to finding solution of a first order linear homogeneous differential equation. This is a very particular case. What order? It can be of higher order. It is linear. It can be non-linear. This one is homogeneous. It can also be non-homogeneous. So I have taken a very basic case. First order and linear and homogeneous differential equation. So the V dot denotes the first derivative of V with respect to W. Okay. So let's say this differential equation is of the form independent variable W, dependent variable V, and the derivative of V with respect to W. Similarly, the second equation. Then, both are, this derivative is with respect to some T. Okay. So both are depending on T. So at T equal to 0, initial value is given that at the initial point, T equal to 0, V is 8 and W equal to 5. So how we can use, let us bring this system of linear equation, this first order linear homogeneous differential equation system to a system of linear equations that we have been talking about since last almost 55 minutes. So matrix form of this will be, so consider this as a column vector. So let us call this as U to be V, T and W, T as the elements of the column vector. So this U will be V, T, W, T, and right hand side again we can multiply the vectors 4, -5, 2, -3 with U. And the given condition can be rewritten as U at T equal to 0 is V equal to 8 and W equal to 5. Now, let there exist a non-zero vector. So now we have got a matrix. Okay, and let us find the eigenvalues and corresponding non-zero eigenvectors. Let there exist a non-zero eigenvector x such that Ax equal to lambda x. Okay, so we usually see in the basic differential equations course that we can consider general expression ut equal to e to the power lambda tx, and then this vector ut will satisfy this equation. So what we have to do, a times e lambda x, x is the right hand side, and left hand side is the derivative of this with respect to t, that is lambda times e to the power lambda t x, and we'll see this will just reduce to the equation ax equal to lambda x, which is true. So putting this is a solution of equation 8, and then rewriting equation 8. So this is what I have just told you. So derivative of u with respect to t is right hand side is a times u. We take the derivative and we see that left hand side equal to right hand side. Now complete solution will be, so if this is one solution, the eigenvalues whatever will have will give us two values of u. So lambda 1 and lambda 2 will give us u1t and u2t. So u1t equal to e lambda 1 tx, and similarly u2t will be e lambda 2 tx. So for this matrix A, lambda 1 will come out to be -1 and lambda 2 will come out to be 2, and corresponding eigenvectors were 1, 1 and 5, 2. So just a second. So it is the same example, 4, 2, -5, 3. So for the same matrix A, we have already computed the eigenvalues -1, 2 and the eigenvectors to be 1, 1, 5, 2. And that is what we are using now in this example. So nothing new. We already learned this. So these are the eigenvalues we already found, and these are the eigenvectors. So initial now, so we want to find, this is the general solution. For a particular solution, what was given to us? U at 0 is 8, 5. So at t equal to 0, v is 8, and at t equal to 0, w is 5. Let us use that. So when we'll substitute that here, so t equal to 0 will give us c1 times 1 times, so in this maybe. So c1 x1 plus c2 x2 equal to 8, 5. So in this we can rewrite, so it will be this matrix 1, 1, 5, 2. C1, C2 being constants can be written on either side of the matrix. C1, C2. No, it cannot be written before because matrix multiplication is only defined. So 2 cross 2 can be multiplied by 2 cross 1. But if I put C1, C2 before this 1, 1, 5, 2, then matrix multiplication is not defined, because that will be 2 cross 1 times 2 cross 2. It's not defined. Anyway, so again, this is what? Solving system of two linear equations in two variables C1 and C2. So that will give us C1 equal to 3 and C2 equal to 1. So the solution is from here, first component Vt equal to 3 times e to the power minus t plus 5 times e to the power 2t, and Wt is equal to 3 times e to the power minus t plus 2 times e to the power 2. So I hope, so because this example was purposefully built on the example of the eigenvalue and eigenvector that we have done, so that we don't waste time. So this way, the solution of this linear homogeneous first order differential equation has been reduced to solving system of two linear equations, and we have got a particular solution with the given initial condition. Okay, so let me go to the next application, which is page rank. Now, what is PageRank? So PageRank is an algorithm most of you know. So it is not only for, so I'm going to come to a particular case. So Google PageRank algorithm. But it is not only for Google, it is for any network of connections. So how much is, so for instance, this is me. So that means I'm only connected to one person. So this can also be understood as a network of friends worldwide. So this is somebody who is having a very good network of friends. And maybe these friends are in India. So if I say, and these friends are abroad, because this friend is having other friends which are still in some other countries. So this is the basic of PageRank. And when we say in terms of Google, so this algorithm was used by Google search to rank web pages in their search engine results. So when I type, okay, so for instance, now when I type applications of linear algebra, so which pages should come? In what order? So tendency is the first, second, third link or options that come. I intend to click those first, and then I scroll down and go to the other options or other pages that can be related to that search. But how do Google prioritize that what comes first and what comes later? Okay, so this was named after Larry Page, one of the founders of Google. And it is a way of measuring the importance of website pages, as I just said. Okay, so how does it prioritize which link or web page should come first? Okay, so let us understand this with a very basic example of a 4-page system. So let us say our internet is very big. So even this is very small for that. So there might be, there is no number. So one thing can be connected to so many things, and when we type something on Google, many options will come. So let us say our internet is very small and consisting of 4 websites, referencing each other in the following directed graph with 4 nodes. So let's say we have only 4 pages. So this can be expanded to 10, 100, 1000, 1 million, everything. So these 4 nodes represents 4 websites. Now we say that website I references J, because this Google search is all about referencing another page. So we say that the website I references website J. When it happens, we add a directed edge between those nodes. So website 1 or page 1 is referring page 2. So we added an arrow from page 1 to page 2. Similarly, page 1 is referring page 3, page 1 is referring page 4. Page 2 is referring page 3 and 4, page 3 is only referring page 1, and page 4 is referring page 1 and page 3. Now, how can we write it in the matrix form? Because this is what we are learning in this lecture. So first of all, we assume that each page or each website transfers evenly its importance to the pages that it links to. So if one is getting linked to 3 other pages, so it will give 1/3 of its importance to each one of them. So in general, if a node has k outgoing edges, so this has only 4 edges. So if there were, let's say 100, and some edge or some node has k outgoing edges, then it will pass on 1/k of its importance to each of those nodes that it links to. Now by assigning weights to each edge, the transition matrix of this graph will be. So for the node 1, let us see column 1. So 1 is not referring 1, so we have a 0. 1 is referring 2, 1 is referring 3, 1 is referring 4. So equal importance gives 1/3 at each of the places. Now node 2 is referring only page 3 and 4, so 3 and 4. And it is not referring itself, it is not referring page 1. Similarly, node 3 is referring only node 1. So here comes a 1, because it will pass 1/1th of its importance to the node 1 and 0 elsewhere. Similarly, the node 4 is just linking to node 1 and node 3, or page 1 and page 3. So at 1 and 3rd position, we are getting 1/2, 1/2. Now note that it is called a column stochastic matrix.
Ma'am, can you write once again column number 3, 1,000?
Yeah. Yes, sure.
Thank you.
Please. Okay. So column number 3 is corresponding to the node 3 or the page number 3. Okay, so that 3, so if you see the arrows, there is only one arrow from 3, and that is to 1. So that means the page 3 is only referring page 1 and not referring any of the other pages. So for our purpose, not referring to page number 2 and 4. So 3 is referring page number 1. So if you remember, the notation was this is first row, third column. So we are here talking about third column. First row means 3 is linking to the page 1, 3 is not linking to page 2, 3 is not linking to itself, and 3 is not linking to 4. Now A is a column stochastic matrix. Yeah, you're welcome. So that means the sum of the elements on each column of A is equal to 1. Okay, so sum of this, third column, fourth column. Maybe sometimes you could have got a 0 column. Yes, who is this?
Yeah, ma'am, I wanted to ask that is it possible that any page doesn't refer to any of the four?
Yes. I was coming to it. Thank you.
And how we would rank in that case?
Yes, I am coming to it. So that's why I have made this one as red, because let's say the page 3 doesn't refer, it doesn't like anybody. So it is not referring to any of the other pages. Okay, so it is not referring to 1, 2, 3, 4. So we'll have a 0 column here. So in that case, we'll do stochasticity adjustment. What does that mean? So if this column, this arrow would have not been there, that is, we would have a column 0, 0, 0, 0. We will stochastically adjust it by assigning equal weights to all the 4 nodes, because at the end we need the sum of the elements of each column to be 1. So if this would have been a 0, then we will rescale it. We'll do the stochastic adjustment by making this column as 1 by 4, 1 by 4, 1 by 4, and 1 by 4. Is this fine? Okay. So now with this matrix, that was just an example I said, that if this one would have been 0, we'll do the stochastic adjustment. Now coming back, we have this matrix. Now let's see how we relate it to eigenvalues. So this is the same. So here in the arrows, I have written this values. So 1 is given 1 by third importance to 2, 4, 3. It's just the same. So we'll denote by x1, x2, x3, and x4 the importance of the 4 pages respectively. So can you please mute your mic? I am hearing my voice back. Whoever is have forgotten to switch on their mic. Then lambda equal to 1 is an eigenvalue of A transpose. So I am not going to find it here because this A, what will be A transpose? Columns becomes rows, rows becomes columns. So A transpose will be 0, 1 by 3, 1 by 3, 1 by 3, the first row. Second row 0, 0, 1 by 2, 1 by 2. Third row 1, 0, 0, 0. And fourth row 1 by 2, 0, 1 by 2, 0. So if we'll find the eigenvalue of that transpose, we'll see that eigenvalue will be 1. Now it is a very nice property of eigenvalues that eigenvalue of A and A transpose are same. So we know that 1 will also be an eigenvalue of A. So next step is to find the corresponding eigenvector for the eigenvalue A. And if we just solve it as in the previous examples, we'll find that the corresponding eigenvector will be some scalar times 12, 4, 9, and 6. Okay, so now that means we can choose C to be anything. Now since page rank should reflect only the relative importance of the nodes, right? Relative importance. Okay, one thing that I should have said, that the more number of pages a page is referring, its importance decreases, because importance is 1 by kth. So if 1 is referring to 3 nodes, its importance is only 1 by 3. But see, the page 3 is so important because its importance is 1. So whoever the page 3 gives vote, it's really important. Anyway, so we choose the page rank vector to be the unique eigenvector with the sum of all entries equal to 1. So what we can do is, we can choose C such that the sum of these 4 entries will come out to be 1. So you can, it is a random thing. You can just do it in rough if you want. If we take C equal to 1 by 31, then our vector X will be 12 by 31, 4 by 31, 9 by 31 and 6 by 31, which will be approximately this vector, and we see the sum of all the entries are equal to 1. Why we are trying to make the entries to be 1? Because what is this eigenvector referring to? This eigenvector is corresponding to the eigenvalue 1, and actually it is a probabilistic eigenvector to the eigenvalue 1. So the probability of referring to page 1 in this diagram of ours that we have considered is 0.38. Referring to point of node 2 or page 2 is 0.12. Similarly, for page 3 it's 0.29. For page 4 it's 0.19. So this was a very particular case of this 4 node page rank algorithm that I have considered. So similarly, it can be extended to 10 cross 10, 100 cross 100, 1 million cross 1 million, and so on. Okay, I hope it was understandable. Okay, so I think I would just skip this. I will just one thing I would like to say, that we can diagonalize any square matrix A if and only if there exists non-singular matrix P such that A is P times dP inverse, where D is a diagonal matrix. So we are more interested in so this was for a square matrix. So what I need to talk about is diagonalization of a non-square matrix. So let me go to that. So that is called singular value decomposition. Okay, and that is more important to discuss at this point of time. So why are we studying singular value decomposition? So most of you have seen, must have at least heard and seen at different places in some research papers and all, relating to, in particular, image processing. There are two terms that come up very often: singular value decomposition or SVD, and principal component analysis, that is PCA. So I am just going to discuss one because of the time limitations. So singular value decomposition is an efficient transform image processing application, including but not limited to image compression, dimension reduction, etc. So I said we are going to talk about diagonalization of a rectangular matrix. So one thing, any image basically can be, so if we see some digital photo lab, sometimes we want to make our photos better, to frame them or to use them somewhere, whatever. Then in that case, one basic idea we should think about is any photo. So whether it is in, like, let's say hard, so you take a hard copy of a photo, you take a scale, and with equal scaling, you divided it into m cross n boxes. Okay, so fine. So like a maths notebook. So the notebook that we used to have in school for writing numbers, right? So that has small boxes. So let's say I have divided my photo into m cross n boxes, right? And I would associate to each box or entry in the real matrix A. So that matrix will be a m cross n matrix. So the idea is to decompose that matrix A as P times D times Q, where D is a generalized diagonal matrix of order m cross n. So I'm going to define it very soon. And P and Q will be orthogonal matrices of order m cross n and m cross n respectively. Orthogonal means P transpose is P inverse and Q transpose is Q inverse. So how do we find A? So I said as below. So what I said, we have an image, we divided it into m cross n matrix, m cross n boxes. Then we got m cross n real matrix A from that. What we'll do, we'll consider A transpose times A. This will be n cross n matrix. Why? A was a m cross n matrix and A transpose is a n cross m matrix. So this B is a product of a n cross m matrix with a m cross n matrix. So this will be a n cross n matrix. Then, so very basic notions. So B will be symmetric if B transpose is equal to B. That is, B doesn't change if we change the columns into rows and rows into columns. And second is B is positive semi-definite, because What is the definition of positive semi-definite matrix? That if we pre-multiply B with the X transpose and post-multiply by X, what is X? X is any n-dimensional vector. Then pre-multiplying here, it will be X transpose A transpose times A times X, and that would simplify to this quantity which is always positive. So B is a symmetric and in fact positive semi-definite matrix, and the eigenvalues of a symmetric matrix are real, and the eigenvalues of positive semi-definite matrices are either positive or zero. Okay, so these are among the basic properties of eigenvalues and eigenvectors. So that means the eigenvalues of this B will be either positive or zero. So it is n cross n matrix. It will have n eigenvalues. Let us denote this by n lambda 1 up to lambda n. Now, since these are positive, let's say even if it is 5, it can be written as square of root 5. If it is 3, it can be written as square of root 3 because they are positive. So once we write lambda is to be square of mu i's, if rank of these are, we have already learned what is rank, then what we'll take the R positive eigenvalues as mu1 square up to mu r square, and all the remaining ones will be 0. So now we are ready to write our generalized diagonal matrix as mu1 up to mu r on its first R as its first R diagonal entries and all the remaining zeros. So basically in the diagonalized matrix, we are having eigenvalues on the diagonal and 0 everywhere else. Now R diagonal values are positive and the remaining eigenvalues are 0. So same will be the entries of D. This decomposition of A as P times D times Q is called singular value decomposition of a matrix A. And note that it is not unique since we have just taken some ordering of the non-zero eigenvalues. So in the previous examples also that we have taken for finding eigenvalues. So for instance, the eigenvalue was -1 and 4. So we just had a quadratic equation and I said lambda 1 equal to -1 and lambda 2 equal to 4. I could have also said lambda 1 equal to 4 and lambda 2 equal to -1. So depending on the ordering of these eigenvalues, the singular value decomposition changes. Okay. So one example, a very simple matrix 2 cross 2, 1, 2, 1, 3. So we'll write B equal to A transpose A. Find the eigenvalues of B, which are 14.93303 and 0.0669. Both are positive. They can be written as square of some quantity, that is mu1 and mu2. Then the diagonal matrix will be, because both are positive, so we'll just scale them. If there, for example, mu2 would have been 0, we would have a 0 here. Putting the value of mu1, mu2, now we'll find the corresponding eigenvectors as before. Then the orthogonal matrix Q can be written as U1 transpose, U2 transpose. So this is basically the algorithm that I have not given on the previous page. On the previous page, on the previous slide, I have just given you how to find D. And then in this example, so you can very easily figure it out to find eigenvectors x1, x2 as in the previous examples. Now to find the P and Q for the singular value decomposition, we have to evaluate U1 equal to x1 upon norm of x. So x is this one. X1 upon norm of x would mean divided by root of square of this plus 1. Okay, so we have normalized this vector. Similarly, U2, that will give us Q, and the orthogonal matrix will be V1, V2, where Vi is 1 upon mu I, A times U. So this will give us P and Q, and hence we'll be getting our singular value decomposition A equal to P, D, Q. Note that if you would have taken mu1 equal to 0.25878 and mu2 equal to 3.86433, then accordingly x1, x2, Q and P would have changed, and that would have given us a different singular value decomposition. So I'm done here, and we have I think around 5 minutes for questions. So if you have any questions, you are welcome to ask.
Good morning.
Yes,
is
please.
it possible to explain SVD by using an example, ma'am?
Sorry, say it again. Is it possible?
To explain SVD with an example.
Yeah, this is an example.
what I meant to say, for a given problem statement, how the steps will be executed.
No, so so that is fine. So given a problem statement, for instance, okay, I don't have that like in particular to show to you, but given a problem statement, for instance, what I said, what is it used for? So image processing applications, for example, image compression and dimension reduction. So given any image, when we want to process it, we know how we want to rescale it. So we want to compress it, we want to reduce its dimension, and so on. And in that process, we get the required matrix. And once we have this matrix, then we apply these steps of singular value decomposition. Let me just try to give you. Let me see. Just a sec. Singular value decomposition. Okay. Okay. So what can you see? Okay. So for instance, I mean exactly here. So maybe I'm not sure, maybe Jiten sir can answer if you are going to have more hands-on or something about these concepts in like Python or something. So for instance, if we have image compression, let me see. So eigenfaces maybe. So this was the original image, and we have rescaled it. So you can see that this is a little bit blurred. And this is a different image. This is so if original image was this one, and then with our corresponding matrix. So this is the image, and as I said, you have taken a scale and you have divided it into small parts, and then you have got that required matrix with which you want to rescale this image. So either you go from this image to this image or this image back to this image. So that depends. And then using that matrix A and then applying that all the steps that we have seen, we can come to a modified image. Let me see if there is something more that I can talk about. Okay, in the meanwhile, any other question? Anything in the lecture that was not clear to you? Any more example? Okay, let me see the chat also. Please recommend a good basic text for linear algebra. Okay, so I would say Gilbert Strang. Let me give you the name. So I would say this is a very good book, Linear Algebra and Its Applications by Gilbert Strang. Okay, anything else? Jiten sir. Hello. Jiten sir. Hello.
Madam, am I audible?
Hanji, who is this? Haan, Joshi sir. Hanji sir.
Yes, ma'am. Jiten sir is busy for 10 minutes. So.
Okay. So should I conclude the session?
If there are no questions, we can conclude the session. and thank you so much for the nice lecture. The attendance link will be sharing soon. Okay,
So
and
there are
all,
these
okay, all the participants are requested to
sir,
join.
please, sorry.
Okay, yes, ma'am.
Please carry on. Sorry.
Okay. Thank you so much, ma'am. The participants are requested to join again at 12 o'clock. Mr. Anup Kekar will be sharing his lecture on data analytics techniques using Python. Okay, that is the next lecture scheduled at 12 o'clock. So,
Okay. Thank you very much, and
okay,
thank you, Joshi sir,
thank you
for
so much.
concluding the talk. Okay. One more thing to the participants: if you have any doubt, you are welcome to write to me your doubts. I will just share my email ID. And if you are interested in any application you want to talk about, you are most welcome. And if you want any reference, you can send me an email, and I will be happy to share the references from where I have made this talk. I hope you enjoyed the session. Okay, thank you very much.
Good morning, sir. मस्टर पाठवायचं आहे थोड्या वेळाने तिकडे, तर मस्टरवर 30 तारखेची सुट्टी नाही असलेली आहे. ते करून घ्याल आणि पाहून घ्याल कोणाचं काय राहिलंय काय लिहायचं. रेड पेन नाही का? येणारच ना ते दोघं बुकिंग येणार. काय कशाच आहे? कशाची कोणाचा संबंधित आहे? नंतर कोणाशी संबंधित आहे ते? आपल्या मला दोघं सांगा येथील थोड्या वेळात विचारून काय मला त्यांचं असेल तेव्हा त्यांनी फोन केला ना. हो आणि ते म्हणे आम्ही याला इलेक्शनला चालू आणि निघालीच आहे मला पाहून द्या ठीक आहे म्हणजे या म्हणजे शाळेकडे तरी आपण म्हणजे आम्ही त्याला चालू इलेक्शनला येत आहेत ते फोन केला होता मी. हॅलो बोला. हो ते येणार दोघं रोहित सर यांनी काही सुट्टी नाही घेतली. अकोड सर म्हणे ते अप्लिकेशन द्यायचं होतं म्हणून मी काही टाकली नाही म्हणून. हा दिली होती सुट्टी तर न घेणार लोक आहेत का ते दिल्यावर येणार नाही. शेकीचा मला आता सकाळी फोन आला आता थोड्या वेळ आधी. मॅडम सुट्टी कशी घ्यायची म्हटलं घेतली काय नाही आदल्याच दिवशी घ्यायची होती. म्हटलं माझं नाव नाही त्यामुळे मी काही घेतली नाही. म्हटलं माझंही नाव नाही म्हणे. म्हटलं सुट्टी कशाला घ्यायचं ते मिळत आहे ते घेऊन घ्यायची म्हणे अरे बाबा उद्या जर ते खाऊन दाखवा म्हणून आणि निळी शाही दाखवा म्हणून दाखवा म्हटले. आणि त्याच्यासोबत ते लावायचं होतं ना आपला वोटर आयडी क्रमांक वगैरे काय ते पाठवा बरं मला जाती देऊ दाखवा. आता पण ट्रेनिंग 12 वाजले आता ते मुलांचे सेमिनार आहे आज टेस्ट आहे माझी तिथं संध्याकाळी जायला NPTELचा कोर्स मागच्या वर्षी केला होता मागच्या वर्षी ते कोर्स केला ऑनलाईन त्याची टेस्ट नाही झाली सकाळी 10 ते 12 किंवा संध्याकाळी 8 ते 10 ते 8 ते 10 ओपन
Good afternoon, everyone. I hope I am audible. We are here to start the second session of the FDP, and we have with us Shri Anup Jayant Kelkar, and the topic for this session is data analytic techniques using Python. So first of all, I welcome Shri Anup Kelkar ji. Brief work of Shri Anup Kelkar. To introduce Anup Kelkar, he completed his MTech in Computer Science and Engineering from VNIT. Welcome, Anup sir. Am I audible, sir?
Yes, you are audible.
Okay. So Shri Anup,
that screen is not shareable.
Okay.
Recently you shared the screen, now it is not visible.
Okay. I think it is visible now, sir.
Yes, it is visible.
Okay. So Shri Anup Kelkar completed his MTech in Computer Science and Engineering from VNIT Nagpur, and he is currently pursuing his PhD also from IIIT Nagpur. We are glad to know that he is the founder and CEO of Springboard. You may visit his website springboard.work. He is the director of Python Academy Nagpur, technical advisor of Tech Quadra, and he has more than 15 years of IT industry experience in data analytics. So we have with us a data analyst. He has also experience of data management and machine learning. We are glad to know that he has conducted many training and seminars on Python, R language, machine learning, and AI. He is also Oracle certified professional. So with this introduction, I request Shri Anup Kelkar to start his session on data analytic techniques using Python. Over to you, sir.
Okay. Thank you, Prasad sir. So before starting the session, Yes, sir.
Okay, you can start, sir. I have stopped sharing. Okay.
So let me share my screen. So just a minute. Okay. So hopefully everyone is able to see the screen now.
Yes,
So as sir already told that today's topic, like the first session and after the lunch, is going to be on how the data analytics techniques we can use with the Python. Okay. And sir also provided the details about me. So thank you, sir. And how I have divided this part, which is a 2-session part, that also I will tell. So before starting anything, let me know if everyone is able to hear me properly. So you have the chat window now. You can just put in yes or no. Okay, good. So all of you, welcome to our session on FDP, specifically related to data analysis, data science, and I have gone through the whole course also, which is supposed to be for 1 week. And I think you have done with the mathematical foundation behind this data analysis or the data science, you say. So that was the session you have done with, and now we are supposed to hands-on experience on this using the Python. So before jumping directly into Python, I will have some details on how this data analytics works actually in basic idea. And then we will actually have a small case study which will continue to be a part of your data analysis and also the visualization. So that will give a full-fledged idea for this. Okay. So let me go to my PPT again. So just a minute. Okay, so that was my details, which has been already provided. So no need to have the repeat of these things. So myself, Anup Kelkar, with all the experience and that, and that was supposed to be there. Okay. So let's say what are the contents we are going to see in this regard. Okay, so basically, as I said, we will talk about what is data analysis is, how it is utilized, generalized steps which has to be followed when you do any kind of data analysis, and basically it starts with the data in hand. Okay, so what are the steps you will follow, and then what are the actual Python libraries? There are many libraries now in the industry, and every company uses their own ways of libraries, or even they create their own libraries also to utilize. So there are various libraries, but all of them are basically on some base libraries. So what are that libraries to be utilized? And then we will talk about a simple case study which I have created for you specifically for data analysis, and then the visualization, that is the PUBG dataset case study. Okay. So again, it was a case study already done by me in between, and now PUBG is banned. Okay. So you may say that how PUBG is coming here. Okay. So, okay, for case study, we can have any data, maybe a China data or any data. So let's have
No,
that.
it is coming back again, sir. It is coming back again.
It will come back again.
Yes, new version.
New version. Indian version or Chinese version?
Indian, sir.
Indian, sir. Then that will be good. So let's have the analysis on PUBG dataset through coding. Okay, so for that coding also, what are the things you should have? And I have made it very simple, so parallelly you also can have some hands-on on that, rather than having some boring stuff that I am only speaking and some of you are talking or having phone calls and having election and all that thing. It will be better parallelly you also code with me. Okay, so for that also some links, some codes I have put it on cloud, so I will provide that link also. Okay, so that is the way the things have been designed. So let's start with, hopefully everyone is there. So lot of people, nearly 90 people has joined, so that is good. So out of these 90 people, I think most of them will be joining through a computer or a laptop, because when you talk about some kind of coding, that thing should be with you. Okay, so if you are joining with mobile, then it will be only a view purpose. Okay, so it's better you grab some laptop or computer nearby. Okay, so that will be good. So let's continue with the actual. So whenever you talk about the data analytics in basic, what you talk about is what is the definition of that. So I have put a very simple definition here. So let me talk about just a minute. Oh, so basically, when you talk about data analytics, it is the process of finding information from data to make a decision and subsequently act on it. So the definition I have put is very simple, but if you go in depth, you will have a lot of understanding about that. That what is a finding information, how to make a decision, and how to act on it. So for that, I generally give a simple example of say a restaurant and an hotel is nearby, and that restaurant is suppose providing us a 1 year of data. So that 1 year of data can be anything. Means it can be only receipt which they have given to their customer. It may be a good kind of say Excel sheet where multiple things are these are there. And yes, you no, the bandwidth is fine, and I think it is better I show my face every time if it is not a problem. You are able to hear me, no? Or there is a problem in volume? Okay, okay. So we will continue, no problem. So lot of bandwidth is there. Now Geo is there, right? So lot of bandwidth is there. Okay. So where I was? Okay. So as I was talking about this data analytics, which is actually a process, and I have just given a definition on that. So for that, I have said, suppose we have some kind of restaurant data or say a hotel data, where we can have a multiple inputs for 1 year. Now that inputs can be in any form. It can be a receipt which has to be converted into digital format by having some data entry operator, or it may be a kind of Excel where you can have multiple columns. So you can have multiple columns in what way? You can have, let's say, a customer name, then what item that customer purchased. Again, I am saying this if it is maintained. Okay, it depends on to that restaurant or hotel if they are maintaining this thing. Then you can have something more on that, like what item was purchased, then what cost was there, how many person came, what day they came, what time they came, it was a lunch time, dinner time, breakfast time, and again how many of they came, 2, 3, 4. So all this kind of data we can collect, or the restaurant can collect, and just hand over to you saying, hey, you are a data analyst, analyze this and tell me what I should do so that I can increase my revenue. So that may be a simple question from his or her end, who is the owner of that restaurant. So once we collect such kind of data, suppose we got it in a Excel format with all these columns. So once you collect such kind of data, what of thing you should start with is finding information from data. So what kind of information we can draw? Any answer you can give regarding the question is, if we have an Excel sheet where, as I said, multiple columns are there, like the customer name, time, items, cost, how many persons, day, or whatever. So on this, what kind of information you can draw manually? We are not talking technically right now. Manually, what kind of information you can draw from that? So any answer from anyone will be fine. Those who are active, I can say, and those who are listening. What kind of information we can draw from such kind of Excel manually? Then we will see how we can do with the pandas and all that. So any answer from anyone? Everyone got my question? What was the question? So both my session should be two-way, okay? Because I like that way. I don't like a one-way that one is there. Yes. So Vinitha has said about the sum. So sum of what kind of thing you want? Don't go for direct summing of everything. Okay, maybe maths is coming from the last lecture, but sum of what? Or I can explain it, sum of means customers or finance. Yes. So again, finance, we are not going in detail of that, but we can say yes, the amount is available, so we can have the finance sum or average revenue or the count. Source can be of what type? Krupas, I'm not able to announce it. Krupu Swami. Source in what sense? Data source? Or should I say Pichai? That is the short. Data source. Yes, that is also most important part. We will come to that also, because when I say Excel, it may be that thing is also available on others, like maybe Zomato, Swiggy. So what are the feedbacks there? What people are taking? So that data source is another data source. Yes, number of customer visit at peak time. That is exactly very good, Vinod. So when I say number of customer visit at peak time, means what I am trying to find out is my location or my hotel is a Saturday Sunday point, or it is a regular point where every time people come. Even in Saturday Sunday, is it a preferable dinner time where people are there, or is it on the lunch time? So many kind of information I can draw. Even what time the people like to visit us. Okay, like in Nagpur. I am from Nagpur, so in Nagpur IT Park is there. So that IT Park has 2-3 hotels where lot many people you will see on Saturday to Friday only. Monday to Friday only. Saturday, Sunday, no one is there. Why? Obviously, because other days there are means offices. Now the offices are already closed, but still offices are closed. There are less people who visit. Whereas there are some places which are the hot hub, like here Dharampet and Sadar are there, which are the localities where Saturday, Sunday more people are coming in. Okay, so it also depends, and we can visualize that thing from the data which we grab. Okay, so this kind of information we can take from the data which I said, and then we need to make a decision on that. What kind of decision we will make as a data analyst? What is our goal? Is to increase the revenue. So how I can increase the revenue? Obviously, selling more items at less duration. Okay, that will be a ultimate aim. There may be another things also, means it is not always you want to increase the revenue. It may be a multiple things you can say on that. So how I can increase the revenue? Maybe if one customer I found out to be a regular visitor within a month, 2-3 times he visit the restaurant, or maybe daily basis or on lunch time or something. So we can have some coupons to that person saying that, hey, you visit regularly, you are our prime customer. Let's have this coupon. You come with 2 more friends, they will have some 20% discount. That is kind of decision we can provide. The second thing, we can analyze and we make him to know that some of the items are very much popular. Like suppose it is a kind of dosa house. So obviously all dosa items will be famous, whereas other items may not have that much takers. So can we have that items club with this item, like a combo offer? Okay, so you take this, you have 20% discount on this another item. And that happens, like if you just go to Domino's Pizza or something, you have something called garlic bread, which is of no use, and we never buy it, but yes, it is coming with 20% discount with a pizza, we may try it. So that is the way, another kind of revenue increment. So there are so many things happens when we just look at the data and try to find out the information. There may be a case only dinner time we have more people we are visiting the hotel, and on lunchtime no one is there. So can we have something buffet or something? Have a 500 rupees coupon and eat whatever you want, something like that. There are many ideas. So all these ideas will come, or the decisions will come from the information which we have, or the information we have gathered from the data we have. Once we have that decision, we subsequently act on it. It cannot be we, it may be a team. Means if you want to understand that yeah, there are multiple stakeholders. What is? Nice explanation. Okay. Okay, thank you. So multiple stakeholders means it is not only you as a data analyst. It may be owner of that restaurant, a manager of that restaurant, waiters who are senior in that restaurant, or even hotel management person who knows about this hotel thing. So all of them should sit together, have an understanding of whatever the things you have came up with, and out of that they will apply something. Means this is the thing you should apply and go ahead with that. Again, that is the way you can go ahead or apply your data analytics. It is not just I am saying that this is the data and you apply. There are other circumstances that has to be measured. So the act on it depends on the party which, or the client I can say, which is providing this kind of analytics to you. Okay, so that is the way anything will act. Again, this action or act may not be permanent. Like for the restaurant, if we say that let's have that 20% discount on your garlic bread, so the restaurant owner may say let's apply this for 3 months. We have to check the result, right? So it will be applicable for 3 months. The data is generated again for these 3 months. Again, it is feedback to you. So the process of data analytics is continuous or circular. It is not one-time activity. It is done and we are okay. So within 3 months, whatever the new data is generated, again it is feedback to you. Again, you have to analyze, you have to find out, yes, it is applying very well what we are thought of. No, then we have to discard that, come up with the new result. Because every time we are just predicting. Okay, so we have to predict, we have to provide result to that. So the process of data analytics goes on and on, because always there will be something new which will happen, and again accordingly you have to analyze the data according to the current situation. So that is the basic definition of data analytics. So data analytics is the process of finding information. Now you correlate with our example from the data to make a decision and subsequently act on it. Okay, so that is a common definition you can talk about. Now generally why there is so need of data analytics currently. Okay, so the main is the generation of large amount of data from not only business transaction, the social transaction, or putting at least the data in Excel sheet. So many people are there, everyone is at least putting the data in Excel sheet or Word format. I mean, there are very few industry also where they will maintain now a kind of register. They will at least put it in a Excel or something. Whenever you put a data into a Excel or in a computer, it becomes a digital. So once you have a lot of digital data, you have a lot of analysis in there. That's why every industry wants to jump onto this and work on this data analytics. While doing that, the second thing which makes it popular is the large data storage available at lower cost. That is important. Even if I am generating lot of data, but to store that, if I have to pay a lot of money, I will not store that. I will discard. But that is not happening. Means if you compare just like my engineering days, 2003, 2002, we have to have a floppy disk, 1.44 MB. And that we have to give to our professor to check our program. It was Pascal that time. And now 1.44 MB is nothing. Means if you have a computer or mobile and you find out a file of 1.44 MB, you will ignore it. You will not at all delete also. So why? Because you have now 1T and 2T of data with less cost. Means you are not paying an exorbitant price of 1 lakh or 2 lakhs to that. So that is happening, and that's why the people are ready to store that data at lower cost. The third thing is availability of better tools and technology to analyze this large data. What happens generally? This is directly correlated to your RAM, because any software, anything will work on what your RAM. So that RAM size also increases. Like again, going back to 2002, 2003, we used to have a desktop with say RAM of 512 MB, which is very high. The person is rich, I can say. He is having that kind of RAM. Now your mobile itself has 16 to 32 and such kind GB of RAM. So that is very huge. And why RAM increases required? Because as RAM increases, that bunch of data you can just put it onto RAM and you can work on that, rather than from hard disk to coming in. Because that happens if suppose you have a say laptop of 2 GB and if you connect 1 T of hard disk to that, it takes lot of time to read it, because reading one by one, 2 GB, then discarding consumes lot of time. So now since RAM increase, already RAM has some cost attached to that, that is there. But yes, RAM is increasing, so that better tools and technologies are also available. So because of all these three things, the data analytics is in boom, and that's why everyone now, even FDP session, most of them will have some either an or AI, ML or DL, whatever the words you use, all things boil down to the same thing, right? But it is going on, so that is a good thing. The second thing you should consider whenever you do any kind of data analytics, the areas which we are going to overview means it is not only a programming or a computer science which is only required. It requires some kinds of maths and some kinds of domain knowledge also. So now this domain knowledge is also required, because whenever you work on any kind of thing, how that domain or the specific thing works, you should have the idea on that. Okay, so it can be a combination of all. And the problem which you may be solving, maybe as your MTech project or PhD thesis or whatever, you have to divide your area in this three divisions. Then only you can think of what kind of programming I will need for this, what kind of statistics I will need, and what kind of domain expertise I will need. So as an example, there is a company in Nagpur. Again, every time I give the example of Nagpur because I live here. Okay, most of the time I know that. So it is a claim genius company. So what that company does, it is working in AI field only on insurance of the damage of any vehicle. So whenever any vehicle get any dash or scratch or anything, we have the insurance on that. And then you have to have the photos and all that things. The people will come from the insurance agency, they will analyze and will provide the insurance on that. Now that process, what they said, is taking nearly 1 month of time to process all the things. So they want to reduce that thing to 3 days. How? Using the computer vision and all that thing. So you will have some kind of app. You will take the proper photos of that. Once you upload the photos will be analyzed automatically. So it is a kind of deep learning they are utilizing on that. And automatically how much damage is done will be identified, and related cost is adjusted, and that will be paid to you. So that reduces a lot of things in between. So while doing that, they have proper teams on that. So they have one team of domain expert where they have some insurance agent, some managers who has retired from the insurance company. Why these people are sitting there? Because they know how actually this domain works. Okay, how then there may be frauds also, means nothing is happening, but still I am showing something is happening. So many things are there. So all these things has to be known from the expert only. So whenever you work on any problem statement, the expertise or the domain expertise will also be required. Okay, so that is the part of your data analytics. Now coming on to that, whenever you talk about the data analytics, it goes with the 3 phases. Okay, so that also I will explain. While explaining, any questions is there, you do put into the chat window. Okay, I have kept chat window upside only. So any question you do put. Are there any slides being presented? No, slides are presented. That was the good question. Are you able to see the slides or no? Yes. Okay. So those who are not able to see the slides, I think who asked the question. Krishnakant, hai na? So Krishnakant, you just check it. There may be another tab. Actually, this WebEx is opening so many tabs. Sometimes it is confusing where you have to click. So are you able to see the slides? You rejoin. That is the best option. Okay. So nothing happening, rejoin or check your internet. That should I will tell always, because that is only I have in hand. So whenever you have any problem, you are not able to hear me or something. But if everyone is not here to able, so do put 3, 4. Counting majority should be there. Okay. Okay. Now you can see and able to check. Good. So and able to see my slides also. Good. So those who are facing the problem and not enjoying other WhatsApp and Facebook, do reconnect so you can see the slides also. Okay, coming back to what we are talking about. So as I said, the data analytics is divided into these 3 parts. Okay, basically when you talk about. So what are these 3 parts? The first part starts with the descriptive analytics. That is the main thing, and that is the one which we will also see in this session and the session after the lunch. So the descriptive analytics is what has happened in the past. So basically we talk about what? what has been done means as compared to our restaurant example, what has been done, it is the same thing. The 1 year of data, that was the past. So for that 1 year of data, we need to take the information out of that. That this was the regular customer. This is regular time when more people are joining in. This is the revenue for each day, or I can say which day is more popular for my restaurant, which customer is regular. So all this information we have been drawing on that. So that comes under the descriptive analytics. Once you're done with the descriptive analytics, you go for the predictive analytics. That is what will happen in the future. On the basis of what? What has happened in the past. So it is again a kind of looking at the past, we try to predict. Okay, so that is what happens in predictive analytics. And basically in predictive analytics, then you are advancing like a machine learning, regression model, neural network, all things will come into the picture. On the basis of data, I am going to predict something. Now that prediction again is basis on data. Okay, so like if I have something predicted on this line and if I want to go above that, how I can do that? If I am to do that, I will come into the prescriptive analytics. That is advise on possible outcomes. So I am looking at the past data. I have come up to the result that I will have this much output or this much revenue. I need to increase that. What are the things has to be happen? And that's come under the prescriptive. The word is very good, prescription. Who provides the prescription? Doctor provides us. So what they say, you take this medicine, you may get cured. So that word should be underlined. So we will also say the same thing, because if you apply this, you may have the good outcome or good revenue. Because when you talk about machine learning, all things, we are not God, right? We are trying to become God, but we will not. That is definite. But yes, we are predicting, as we say, Bhavishyavani. So we are just providing the prediction on the basis of what? What is your past? Okay, that is only the thing we can see. And yes, with our expertise, we can add in some additional things. Like we are going with understanding that yes, we can apply this thing. Then you can go ahead with that. Okay. Sample, example, practices on the topics covering in this session. Parallel. Parallelly, we cannot go ahead with that because, as I said, we will have a complete case study where we will do this directly from the coding point of view. Okay, so otherwise it will be too vast topic to discuss. Okay, so let me complete this part and then we will jump on to the practical coding session. Okay, so that is for Prem Kumar. Okay, so that is the way prescription will happen. And again, as I said, once the prescription happens, you have to jump on to the descriptive analytics, because this one you will apply for some duration. And as I said, some duration can be anything. Means for restaurant example, 3 months is sufficient to get the idea what things are happening. But if I am working on some weather forecasting or something like that, you may have to wait for 3 years because the cycle will repeat accordingly. And if you are working on some share market prediction, it may be 3 hours, which will be sufficient, because within 3 hours you have the result, you apply it. Okay, so that is the way. It depends on which duration you decide. What duration is decided, accordingly you generated, you will get the new data generated, and that has to be applied again. So that is the section, that is the way it will be applied. And out of that, for me, 2 sessions are on descriptive analytics, so we will have the practical example on that. Not on predictive or prescriptive, because that are the other sessions for you. It has been designed accordingly. I have added some examples on that, like the descriptive analytics, which generally happens with many things. So it is like a Netflix. No, not only Netflix. We have so many OTT platforms, maybe Amazon Prime, Sony Live, and so many. So generally, whenever you watch some 1-2 movies, you will see after that they will start giving you the suggestions or the recommendation that if you watch this movie, you can have this, you can. So what this is, it is an insight into the past, because each movie got attached with lot of genres, right? Means it is an horror movie, romantic movie, or a comedy movie. What was the villain or the hero, heroine? Accordingly, they have a set of data which are attached together. So accordingly, once you watch 2-3 movies, they get a pattern of yourself that all this we can apply together and then come up with a new thing. So that is the way the descriptive analytics happen, and it changes. Like I can tell you another example. Like when Amazon Prime we purchased, I used to watch the Hollywood movies, and my son, he is 7-year-old. He used to watch the Chota Bheem and all that part. So after some time, the recommendation got mixed up. That is maybe 1 year back or 1.5 years back, because both are giving the different ideas, past data to them. So now if you see, we have a proper kid section and a general section. So this kind of thing should not happen. So how they may have got this idea? On the same line, they may have got the request from the customer that this is happening, and they come up with these two separate entities. So for kids, separate decision will be made, for others, separate decision. So that is the way you can proceed with that. Okay, so it depends on data to data. Yes, what is the question? It can be of general analytics. That's why I said it means when you call business, it is obviously always a revenue. But when you call it anything, means even like currently COVID was going on, so there was a case like how through X-ray I can identify if a person has a COVID or not. So that was also going. So in that, what will happen? Input will be multiple images of the X-rays, and again it is a kind of classification data. Like this many X-ray images, they were positive. This many images, they were negative. So on that, first getting that kind of information through images will be a part of descriptive analytics. And then comes the predictive analytics. Then prescriptive will be an actual how this can be avoided if you are on the verge of getting in that side. So it can apply to anything. What I have put is a generalized view. Okay, so that is for Vidyut Deshpande, Dr. Vidyut Deshpande. Okay. Second thing, when you talk about the predictive analytics, it is actually you get the prediction, like a grocery cashier know to hand over you the coupons you might actually use. And this happens, means if you have a simple example of our Big Bazaar, they generally provide you a kind of coupon, say 500 cashback and 600 cashback. But how it comes? 100 rupees for 5 months. Means every month you have to go for 100 rupees, and you are not going to buy for 100 rupees. Obviously, you buy for more, and that is an additional thing for them. So that is the visualization they use and they apply. Big Bazaar is a very good example or a practical example where you will see a lot of data analysis. The owner of Big Bazaar, what is his name? Kishore Biyani. Okay, so he is the owner of Peter Group. Now it has been sold to Reliance and all that thing. But he has come up with a book called It Happened in India. So anytime if you get time, you do read that book. It is maybe 8 or 9 years old when he came up with that book. But the book is very good how he created the empire, the Big Bazaar empire. And most of the time when you read now, you will find out it is a data analysis which is happening. So one by one example, like when you stand in the Big Bazaar queue for payment, there will be a queue where you have to stand. Okay. And while standing there, you will have nothing. You may have your child at your hand, maybe crying or laughing, whatever. Or you may have your WhatsApp and Facebook, or you call some friend. While going there, you may see on left and right side some small buckets with some very small items, maybe a socks, maybe a candy or something. Why they have put there? They are already there. But since you are standing, you will take that also. What is this? Oh, sock. That may be useful for me. You will put into the bucket. Once you put into the bucket, that is an additional thing you have added without knowing that you are supposed to take that or not. So that is the kind of data analysis is happening. Means that is a tendency of the humans that okay, let's take it, and you take it. He has given a very good example there that when they analyze the data, one customer they found out that customer monthly, regularly within month, visit the Big Bazaar once and buy a T-shirt. That is his hobby or whatever. So how to increase his intake? What they decided next time when that person buys a T-shirt, they provided him a coupon of coffee mug. So next time you buy a T-shirt, you will have a coffee mug with 50% discount. And obviously, if he goes there, means next time when he comes, since the coupon is in hand, he may move to that section also, which he was not going at all. So if he moves, that is well and good. If he buy, that is very good. Okay, means he got a new section to know. If he doesn't buy, that is also fine. That is no loss for the company. Okay, but if he moves to that section and if he remembers, array, that is another section which has lot many things. So next time when I visit, let's go to that section to check. So that is your vision they are increasing. Nowadays, one Mumbai company where I have a talk with them also, they are now focusing on videos, CCTVs, for taking the expressions of the customer to know if that person is going to buy that thing or not. So if they get the expression that he is ready to buy that, at the same time, a salesperson nearby will get a ping that you go to attend that customer, so he will definitely buy. So much advanced things currently going on. So many things are there. So not to go in that examples. Okay, and then goes for the prescriptive where always you will come up with a suggestion. Like today, if I want to book some ticket from say Mumbai to Delhi, and I will just open the website and there will be multiple websites, Go, Bigo and all that stuff. So many websites will appear. Even if I don't buy and close that thing, after 2-3 days, if I open something, you will find out on left and right side, the ad will be popping up saying, yes, you buy the ticket, you will have 50%. How they know? They are continuously monitoring you. Why? Because they have to prescribe you something and you may buy it. Okay, so that are all things happening all around, and that is all kind of data analytics which is happening. Okay. Now coming to our Python, because we are going to do this all things in Python. So I have some slides just to explain why we are going to learn about the Python. So obviously most of you must be knowing it is an easy, open source, expressive, high level language. So all the good data types are available. It is a portable, so you can have a .py file run anywhere. It is slow because of the interpreted thing, but yes, for data analyst it is fine to tune it with the Spark or something. And then it is actually an object-oriented, extensible, embeddable. Large standard libraries are also there. In extensible, we can have some view and all that things available as in packages. So you have some C++ code. Still, you can run that code and come back to your Python compiler. So that kind of attachment also they have provided in extensivity. The language is dynamically typed. So that is the most important part. Dynamically typed means what? There are two kinds of types, static and dynamic. So when you call it a dynamically typed, in general, like in our C, Java or anything, whenever you create any variable, you have to define its data type, like integer I, character C or whatever, and then start utilizing that. That thing doesn't happen in Python. It is dynamic. That means if I write I is equal to 2, I have an integer which is of I, and if I write I is equal to Anup in the same session, the same variable changes to character, and that is the main thing you should remember. Sometimes it may be a problematic for a person who has the view that this say variable should belong to that variable. But if you start exploring like the function calls and all things, it becomes very handy. Okay, and that's why the Python is in that use. Okay, so dynamically typing thing you always remember when you work on the Python. And the best thing is it is a good fit for data science, ML, and all the techniques can be used easily. Now coming to the libraries, which also we will also see regarding to the Python for data analytics as other also. So the basic libraries which you are going to see is this one, which you can see on left side, basically the matplotlib, seaborn, pandas, numpy, scipy, and the sklearn. These are the actually libraries which are specifically used for data analytics. Very basic library with lot of functionality. Okay, means if you start exploring one by one libraries with one by one data types in that, it is a huge. As per your need, you learn what you want and you can go ahead. That is the only thing I can suggest. But that is there, that is required, and that has to be done. But while doing that, it may be a parallel thing you can explore on your own if you have interest, like the Scrappy or Beautiful Soup. These are the libraries for web scraping. So you can scrap the data out of that. You can have Pillow, OpenCV for your image processing. You can have Flask, Django, Pyramid as the web development framework, or you can have PyGTK, Pygame to game creation also. So these libraries are all in parallel, so you can use them also if you want to go in that direction also. Okay, so that may be the case in the future. The generalized steps which we perform in data analytics I have shown here. Why? Because in this process, this pre-processing is the part which we are going to see today. Okay, because the other part, like the making a predictive model, performing visualization can come on this pre-processing time also or after also. Even if you are a good graphic designer which has a good idea of having a graph, that may have a good position as data analytics in the industry, because many a time you do data analysis, but if you cannot represent them properly to the client, it gets rejected. Okay, so those who have a good graphical skills, how to put a bar chart, what kind of colors you can add in it, what are the proper labels you can provide. So all these things you can do with that. Okay, so that is also there. Difference between difference means Pillow is a very small library. Means Pillow you can use something like making your image to grayscale or something. Whereas OpenCV is extensive. Every time you have new addition in that. Okay, so that is only the difference I may know because I am using the OpenCV directly. But Pillow as a starting point, if you are doing a simple image processing like tilt a image, make it invert, or had some multiple images by just having a distortion of the same image, so you can have multiple training points, that time PIL or the pillow will be useful rather than having OpenCV. OpenCV is heavy also. When you install, it has multiple things you have to apply. Okay. That is the difference you can say on that. Okay. So that is for Sanjeev. You got it, Sanjeev? When I say yes, so these are the generalized steps. Again, each step, how much time it takes, it depends on what problem you are solving. Like some of that step may take a 1 day or 2 day, or maybe taking a 1 month or 1 year also, depending on what data you are utilizing. Because all depends on kind of data, the domain, and the result you want. These three things are connected, so that has to be predefined first. If you start changing it after doing some kind of thing, again it is difficult to come back to that position. We have to go back to zero again, okay? Because you are changing the requirement, okay? And that also we tell the client, make it fix what you want. Once you make it fix, then we will start working. Because what happens, client in EAB add kar do. What do you mean by EAB add kar do? That doesn't happen, right? When you say specific, that is from client point of view. For your MTech or thesis in PhD, you can think of how I can go ahead with that. Okay, means what is my aim? So that's why we always say, you fix the aim, then start the journey. Okay, so then otherwise you will be aimless, right? So here also the same thing happens. So as a data source, one of you also said at the start also, data source matters. Means it is not only Excel for a restaurant, it may be how the comments are coming in Swiggy, Foodpanda for the same restaurant. Because that also gives a good idea, okay, and then you may have some NLP in between to analyze that comment. Okay, so that is also an data source, and you have to automate that source. Then the pre-processing. Now this pre-processing consumes lot of time. Means it is actually, I can say, an 80% of your analysis will go in this pre-processing. As an example, like you have a restaurant where we have said previously, and the data is there. And suppose we found out there is a one row where the amount is missing. Okay. So if that amount is missing, what should I do? I cannot delete that row saying amount is missing. I should pre-process that. Pre-process means fill that value with some other value. Now, what kind of other value we can think of? What do you think when the amount is missing? Say billing amount, okay, and if the billing amount is missing at particular places, and don't consider items, you can check and apply. Yes, that may be one of the case, but it may be the case within a year, item rates are also changing. Yes, average. So Vanita has said correctly. Average is the all billing amount average you apply there. But again, there is then the problem is average of 1 year or the median of, again there are average, median, mode. You must have done in maths recently. I hope so. So when I say the median or the average, if I try to apply, it is of 1 year, which may not be useful because people may have the breakfast, the amount will be less. The people may come on dinner, the amount will be high. People may come on lunch or in between, have some dosa, idli, vada, whatever. That may be different. So average may not be proper way of going on. Or if you are doing average, you do the sampling first. Sampling in what sense? That row, even if the amount is missing, let me see what are the other columns. So you may have the person came for lunch. There were the 2 persons. The day was Monday. So what I will do, out of the whole data, I will first filter out what I want is the rows where the day is Monday, the time is lunch, and there are most of the time 2 persons are coming. So once I select that only data, it may actually comply with what the missing data. And then if I take the average, that will be more accurate to put in rather than just the average of whole data. Everyone is following this, what I am saying. So that will be a good part for that. Scaling and normalization part of it. That will be separate thing. Means what I am currently telling is pre-processing for filling or the cleaning of data. What you are suggesting, Sanjeev Kumar, is scaling or normalizing. That means like I have 2 columns, one have the values 10, 20, 30, 40, and another column that may be age, and another may be a salary, say 10,000, 20,000, 30,000, depending on your age. So now if I apply both the columns, machine learning is what? A kind of mathematics only. So if both of the columns is going in numerator, the salary column will affect more, obviously, rather than this age column. Whereas both of them, if going in denominator, the age column will affect more rather than the salary column. So I don't want that dependency. So if I want to remove that, I will normalize. Then you have some range normalize or Z transform or all that thing, right? So that is the way you can normalize it and then apply. But that is a separate thing. What I am talking is missing data has to be replaced. You cannot just reject that row. Otherwise, you may come up with lot of rejection and very few data will remain. Okay. What if there are millions of record and some do the data is missing? Yes. So again, whenever you say millions of data, there are then two combination. Means when you say millions of record, some kind of data analysis is there, but now how to access that record or data? So you may have to fall on to Spark or Hadoop, because that is also important. How you get that kind of data at hand and then you process. So it depends on the record also, means what process you are designing and how you are going to access that data. Okay, so that may be not a pre-processing, that may be a technical from how to fetch that data, millions of records. Or even you may have to come up with some additional GPU and something. Okay, so it depends on problem to problem. Okay, that is from Sanjeev Patel. Okay. So millions of data, again your RAM may matter, your GPU may matter. Now TPU is also a new thing, that also matters. Okay, so that is the, but yes, whenever you dealing with the missing data, it again it depends on the problem. Means if the problem says let's remove that atom or the row which may not affect anything or not, we can go and delete that because some data is missing. But that also has to be decided. Okay, so that depends on problem and your actual output which you are expressing. Okay. That is big one from Mekala Girish Kumar. Okay. I found so many data sets in various websites in the form of .csv or Excel, but in real time it will not be available as much as easily possible. Yes. How to learn to access or collecting data. Now, if you are talking about collecting data, means is it for your particular problem which you are solving for your thesis or something, or what? Because it depends. Means when we work in industry, the person who comes, like there was a person who want a chatbot for their medical company. So that time they said we have some old data where we have the conversation of our call center guys and the person who are putting the query. So that whole data they have provided, and on that basis we started building the chatbot. So that is coming from them only, because it is a medical data. It cannot be given directly. Okay, we have to have to sign the bond and all that thing. So that depends. So collecting data is again a kind of unanswered question. Means it depends how you want. But I can suggest if you learn some kind of web scraping, again you say it is illegal or legal, it is in gray area. You decide. So web scraping can provide you access the data from websites which are not providing that kind of data. Maybe the images or maybe, so if you learn web scraping, basically Scrappy and Beautiful Soup. These are the packages in Python, very useful. So you can have a hand on that. Okay, so if you got that idea, again there are problems. Means once you start fetching some data from web scraping, your proxy will be identified, then it will be blocked. So then comes the proxy rotator, which will rotate the IP address and you page. So many things are there. Okay, so it depends on what problem you are solving. So why I am putting this question, as we are dealing in micrometer, nanometers, and it was affecting our final. Oh. That is again a very different field for me also. But what is that dealing in micrometer and nanometer? That is, means it is specifically for images you are talking or something different? From Sanjeev Patel. So it depends on how you collect that data. Okay, I may not answer that question, what problem you are solving. But web scraping can be an answer if you want to take it, I can say illegally. Okay, you should not tell illegal things on FTP, but that is only the way if the data is not legally available. Okay, so coming back to our thing which we are supposed to go ahead. So now talking about the case study which we are going to see. So the basically case study why I have selected is the PUBG data set. It is a very common, everyone plays that and specifically everyone enjoys that. So some of the details I have provided, that the battle royale style video games have taken the world by storm nearly. So what actually in this battleground or the PUBG, those who play well and good, those who don't play, I will just provide a simple idea what this is. So it will be easy, because as I said, if you don't know your domain, working on that is just like a robot. Okay, so you will be a machine learning robot where I am telling something and you are writing. That should not happen. Okay, so let me explain. So PUBG is a kind of a game which is the long form is given here. It is players unknown battleground PUBG. So they have provided some battleground. Maximum 100 players can play at one go. Okay, and then there are things like a person can play as a solo, as a duo, means two friends can play together, and then a squad where 4 and more persons can be added. Now they have a lot of new ideas. And what they have to do, it is just the survivor. So whoever you see, you kill that person. So while killing that person, again, it may not be a very good from cultural point of view, rather than having building something they are destroying. But yes, that is the game. So while killing something or something, they have provided multiple things. Like you can have different vehicles to drive in or to have something. You can swim through, you can run. Then you have multiple gadgets and hand, like maybe sling sorter and all that thing that also comes. And while doing that, you also may get shot. So they have some healing power also, some medicines and all things you have to grab up or take from your brain or all that thing. And that is the way the thing has been designed. And then accordingly, the ranks will be provided. Means you are the first in this game, second and third, and that is the way the game is played. Okay, and that is very popular. So this data has been provided by PUBG itself to find out which person will survive. Okay, that was the actual question. But we will break it to just to get the columns out of the total columns provided, just to check which columns will be useful to identify the winning percentage. Okay, that is the thing we will do. And then how this person will win or not, that comes in the second part, machine learning, which is not supposed to be in our case. Okay, so that is the way we will go through that. Okay, so everyone got the problem statement what we have. I will have two slides here also, so you may have the more idea. So has made it official, the data has been made official available for public. I have also loaded that. I will just provide you the link for that. So what in this case study we will do, the PUBG is that we have been given a simple CSV file. Okay, again we have the data in CSV because they have provided, as the previous question has sent you, that you may have data in any format. But most of the time when you do the data analysis through Python, you may have to call down to some CSV and then analyze that. Okay, whereas you go for some deep learning, images can be directly taken and pixel wise data can be adjusted. That is a separate thing. But here you can go ahead with that. Okay, so that is the way you can proceed with that. So in the given case study, we will do only the EDA, that is generally called the exploratory data analysis, to understand the patterns of the play by analyzing different columns of the data made available to us. Okay, so let's have the data to do the talking. So before jumping into that, I have just shown what kind of data they have provided. Okay, I have broken into two rows, means the columns into two rows. So the first are just the IDs, ID, group ID, match ID. Now from here, all the columns start. So I have added the column details also in the actual code. So assist, boost, damage, DBNO, headshot, heals, these are the other columns. The right distance, all these different columns are there. Winning points, that is the winning place percentage. That is what we need to predict if you are going for the machine learning. So what this is the value, it will be between 0 to 1. So as it reaches to 1, your winning percentage increases. As it reaches to 0, your winning percent decreases. That is the common thing. So this may be your Y if you are talking about X and Y. All other columns may be X, but we will see we don't need all columns. Some specific columns are sufficient to have this Y output. Okay, so that will be our case or problem statement which we are going to solve. Now, how to access STF file in Python and how to upload. That will be out of scope for me. Okay, so for HDF5 we have a package for Python with the Hadoop, and then you can access, or directly also one function is available. What was its name? I did not remember, but you can do it that also. How to identify which column to select. So that will be actual our part right now and after the lunch, to identify column to select. And again, there is no written rule. I have applied some function and I got the column that will be applied. It is through analysis you will find out, okay, these are making the output more positive, these are making the output more negative. Okay, so no simple measure is there to identify this column works, this doesn't. And for each problem statement, it will be different. Means even if I am telling this to you through my coding, you may come up with some different idea. No, instead of this, let me apply this column. And you can go ahead with that. And if you got more result, I will accept that. Okay, that is more important column than what I said. So data analysis is like something, there is no written rule or no final thing. Means whenever I teach, that time also I tell that there is not going to be any written rule. Okay, so it is the simple thing. Whatever you want, you can go ahead, or whatever you don't want or no, not using that, you can reject that. Okay, so that is the way you can go ahead with that. Do you have any too many questions which I left? How to identify? Okay, that is done. Do you have any tool to add? That's why I said you cannot have any tool. Yes, in generalize you can have simple tools, that dependency find out or something. Otherwise, it is no way to identify if a tool or no tool available to identify if column is important or not a function also, as I said. Okay, that is for Sanju. You have to go with your data, you have to identify, and we will see in this case how we identify. Okay. Suggest some online. Yes, so that is my second question to you, all of you. So we have to do the data analysis. So there are two ways. One way is you can have your own Jupyter, because it is a Python. So it is best way I can say you can install Anaconda. Okay, so I will just write anaconda.com. I think most of you must be knowing of that. It is anaconda.com. So this is the website where again the size of Anaconda software, it is open source. It's I think 400 or 500 MB. So it may take some additional thing to download that. Okay, why I am saying that once you download, it comes with all the libraries, pandas, numpy, c1. You don't have to install it separately because it consumes time. Okay, so that is one of the things. Second is Python default editor ideally is also good, no problem, but only the thing, then each library you have to install. Then you will have multiple errors and I cannot tell all these errors. Okay, so that is better. NumPy pandas work with ideally, obviously. Only the thing that library should be in your system. Okay. It is Atom is also good, no problem. Any editor you use, I don't have any problem. Why I have suggested Anaconda? Because all libraries comes with that. Because whenever you do data analysis, as I showed on left side, we should have the NumPy, the matplotlib, c1. If they are not there, that need to be installed first. Okay, so that should not be the case. So that's why I am suggesting to go with. Otherwise, another example I will say Colab. All of you can just jump on this. Google Colab. Okay, so I will just open here and share my screen. Let me see. Colab. Okay, so if okay, I have to share that screen. Okay, just a minute. I will remove this screen. How to? So all of you are able to see my screen. This is Google Colab. Where is the chatting? Okay. If you are using Jupyter Notebook, that is also fine. Make sure the libraries are there. Is this free? Yes, we always use what is free. That is our tendency. We never pay for anything. So it is free for Sanjeev Kumar. Okay. So yeah, Google Colab is free and that is very good to work on. Okay. So in the future also, rather than installing anything, you work on Google Colab. So you just click on that. It actually opens the window and it asks for you to open anything. Means it actually opens the Jupyter file. So you can just click on new notebook and a new notebook will open. Okay, so just wait for some time. A Jupyter notebook will open. And the good thing is it has provided all the libraries inside. You don't have to install anything. Okay, so that is the best thing about that. And that is the Jupyter notebook open here. Now, before jumping into this, consider the case study. Second assumption is all of you have some idea about Python. Is it correct? Or I have to have some 2-3 lines here just to show what happens in Python. All of you. Okay. If someone has no, that no is also possible to come here. Okay. Don't hesitate. How I can put no there. It happens. Everyone has different lines. Everyone has the idea. That is a good thing. So generalize in this OLAP, how you write the code, you write here, like if I say 1 plus 2 and click here, so it runs the line. For first line running, it will take some time, but you will have the result. So I think many of you are from Andhra and Telangana also. I have visited many colleges there also. I don't remember if you are from that college, like Mala Reddy or Pulaiya. I don't remember. Okay, from NCR. I have many FDPs there under NIT Warangal. NIT Warangal was conducting that all things. Somaiya Julu sir was there. So under him, I was there at many places. From Tadapalli to Tirupati. Yeah? So many colleges are there. Okay. So are you able to run this code? You have to click here to run this code. PKR engine. Okay. And anyone from Matosri or Hyderabad? That also. Or CBIT or something, right? 2, 3 colleges, big colleges. SV University. Oh. So are you able to run this code? It is simple. You write the code in this cell and you just click on run. So it will run there. So anyone facing any error at this point? Zoom the screen. Okay. Yes. Now is it visible? It is you write the code here. That is for Binsi Rashad, and you just click here. Okay. So once you click, it will start and it will run. Yes, Prem Kumar is very eager for coding. wait. Let me have everyone. Sabka saath, sabka vikas. So don't be in hurry. So let me have everyone ready with this. Then we will start. Okay. And that is the new line is you click on code. So the new line appears where you can write another code. Say print. Okay. It also runs here. And the second text is if you want to add the headings. Currently we will not go with that markdown language. It is a kind of markdown. But that is the way every time you click and new codes appears one below another. Okay. So considering everyone is ready with this, is there any approach how to identify the type of ML technique to use for particular problem at hand, or we should try on? Yes, that is the answer you have given. There is no, even if you have a simple problem or complicated problem, there is no way to identify what ML or what kind of ML. Maybe a regression, neural network, KNN, or whatever you say. Which one will apply? Again, we can at least divide the problem into say regression or classification depending on what we have, or you have something clustered. And then on the regression, we can have multiple ways, maybe a decision tree, maybe a regression model. And in every model, you have lot of hyperparameters. That hyperparameters is again what? Again, is it out of what we are doing? But still, hyperparameters are the parameters or the variables which make the output as desired. Okay, so that has to be tuned. So how much tuning is possible for particular hyperparameter of particular algorithm, that depends on what kind of data you are feeding. So again, there is no way to identify which ML will work for which problem. It is on all. Okay. But still now there is one transfer learning things, means if the problem is big and can be divided into particular chunks, some of the chunks may be generated or created by someone else. So that deep learning model using the Keras you can put inside, and then left and right side you can consume. Okay, so that are the things you have to do. Okay, so it is all experiment. Okay, Again, experiments on hyperparameter as well. Yes, that's why I said, means even if you say, okay, this model will work for my algorithm, hyperparameter again tuning will be a second. So the way is just going on. So it depends on what you do. And the problem is, if you search some research paper or something, you may have the images or something. You never have the code in that. So again, you have to come up with something. I will suggest someone should put the codes also. There are codes, lot of codes on GitHub and somewhere. But still, some proper paper you may have to improve. That paper don't provide that code. You may email that person is happy with you, he or she will send that. But if it is not, again it is back to zero. So will you repeat the steps for Google Colab? Okay, Google Colab is nothing but in the Google search, you write the spelling Colab, C-O-L-A-B. Okay, and the Google Colab will appear. And just you click on new notebook. So this new notebook will appear. So for Vidyut Deshpande, Dr. Vidyut Deshpande. Do we have hyperparameters in multiple linear? Yes, everywhere the hyperparameters means which one you call hyperparameter, which one you call variable. Because even in multiple linear regression, you may have y is equal to say m1 of x1 plus m2 of x2 plus m3 of x3 plus b. So now this m1, m2, m3, b will be what? Hyperparameter. In this world, in industry, may not know what happens in academics. In industry, they are very much hype about using different words like data wrangling, data cleaning, then data aggregation. All boils down to pre-processing. But people has to sell that idea, right? So when we sit on client, oh, data is very big. Data wrangling has to be done first. So client get happy. Okay, something new has to be done. But it is nothing but some SQL join. Like we can have and left join, right join, but the word data wrangling impacts. Okay. So you say it hyperparameter. If you don't like to say it, you don't say it. But hyper is a good word, right? The people also get hyper. Hyperparameter has to be tuned. So your guide will be also. Now Prasad sir will tell a lot of bad things I am telling. Okay. So do you have hyperparameter? Okay. Going back. Now, what is hyperparameter? Well, hyperparameter is nothing but the variables in your machine learning algorithms which need to be changed so you have a proper output. Okay, in simple word I am saying. Now each algorithm, maybe a decision tree, neural network, linear regression will have their own variables which need to be changed. That is called tuning. Okay, so that is hyperparameter. Not in our case, our is data analysis applying using Python. Data analysis concept applying using Python. Yeah. I didn't get your question, Vinita. Means back to our topic. That's what you are saying, if I am not. Okay. So that was supposed to be the case. Okay. So let me open. I have done my this code in Jupyter. So I will just show you the Jupyter file for that. So let me see if it is shareable. Yes, it is shareable. I will increase the font. And let me share this. Okay, so this is the GitHub location where all the code. Now this code is in IPYNB format. Okay, so those who are new to Jupyter, let me tell that is a Jupyter file. How to load into Colab, that also I will say. Those who know, they have to just put this IPYNB file into their folder. So all the things will be available. On the same GitHub, we have provided the data link also. So from where you can download the data also. Once you download, obviously I will explain one by one step how to work on that. While there may be some error, some problems, we will sort it out and we will go ahead with that. Okay, so the data is also big, not big, but it is some kind of lot of rows are there. So you do download that data, do download that IPYNB file. And once you have the IPYNB file, those who are working on Colab, there is an option here. So those who are working on Colab, just see here, there are the options. So here you can load that IPYNB, okay. Or you can load from GitHub also. I think it was option there, not there now. Okay, so you can load it from here, from your machine. So you download the IPYNB file, the CSV file, and both you load from here. Because the code needs to work with the data which has been provided, and that has to be work in Colab. So all things has to be there here. If you are on some other things, not on Jupyter, not on this, what will happen? The problem will be the file is not .py file, it is a .ipynb file. But you can convert that into py. Okay, so those who want to work with Atom or any Ideal or anything, you just open it in Colab, okay, by loading here, and then convert it into Python. Okay, so that is also possible. Like if I go here and where is the option? Download as py, so that ipynb file will be converted into py file, and then you can run one by one statements in that into PyCharm or whatever Atom you are running, because if you run as a whole, it will just run without giving any result, because the data analysis is not something you have to show as a result as a final. It is a step by step process where we analyze, get the result, you go ahead. Okay, so we have to go ahead in that fashion. So all of you do download that. What is downloaded? GPU, how much it is actually, it is given there. If you just look at the PC, see here, if you click, I think 4 GB or something has been provided, but you can purchase also. They have provided that option also. Okay, so you can purchase the data and then utilize it for your purpose. Okay, so that is also there. I think 4 GB was when I was using. Maybe they have increased or what. Are you able to find what is the size given? Here they are supposed to give the size. It is there. Okay. Oh. See here, it comes here. So it provides 12 GB of RAM. Sorry. So that no, GPU is not there. I think the RAM is 12 GB and the disk space is 107 plus 31 GB occupied. So nearly 150 GB, something like that. Okay, you can say. Yes, the file size is big. Even if it is text file, maybe you don't open it directly. If you have the notebook plus or something, you can open it. But I think it should be .csv, not txt, right? I think someone mic got open. You do close your mic. Okay, it got closed. 148 participants. Oh, too much. Okay. CSV file. That's why I said. Who got that text file? Means CSV file you can open in text also. That is not a problem. So everyone done with that? Means, are you able to load that to Colab if you are working on Colab or into Jupyter? And the habit is once you get everything, we will start working on the code and we will have a lot of error. So I will say wait, let me go one by one step. Then you analyze and go ahead. Okay. Otherwise you will be in too fast to run all the things and done. So no next session is required. That should not be the case. So have piecewise all the things. Okay. It is downloading. Okay. So it is better to have break then. Prasad sir. Sir is there. Yes, but I didn't find the link Jupyter public GitHub link. Didn't find the link Jupyter public GitHub link. You will have the download option there. No? You don't have that? Which one is not coming as CSV? The input data? Abdul? Still download it, let it complete. So it will be just .csv or .txt. That will be a difference. But still the Python file means read underscore CSV will read it. So what is the problem? Prem Kumar? And Selvar P also has the problem. How to download? There will be a download option. Let me check if they have changed it or what.
Hello, Anup sir.
Sir, is it nv2.zip?
Let me open. I have opened it. Where is that? Let me open it.
That is second tab, sir.
Okay. So this file download option has to be there. Now they have changed this. Okay.
So you have the link at the bottom. The data set is at the following link.
Yeah, the data set is here and the IPNB file is here. Got the idea?
Okay.
Okay. So two different things. This is the code. Yes.
So the IPYNB file, how to download that, sir? I could download the data set, but the Python file is not being able to download.
There will be an option now.
Sir, I'm working in idle. So will this get downloaded and loaded into Python idle?
So as I said, those who are working not in Jupyter, this file will not work there. So what you do, you run it on Colab. Okay. So you have to upload on Colab, or once you upload on Colab, like how you will upload, you will go here and then upload that file which you downloaded, IPNB. And once you click, it will open here. And once it opens, the one thing you can run here itself, no need to go there. Else you can go and download as .py. So it will automatically convert to py file.
Okay.
Even it will open in ID.
Okay.
Hello, Anup sir.
So that is for, and for downloading, there should be an option. Let me see if I open it.
This is how the page looks for us.
Yeah, this is a Jupyter. See here.
Yeah, this is how it looks. Yeah.
Can you see that?
Yeah. Yes, sir. Yes, sir.
No. So you just download it. Are you going to work on Jupyter or something else?
Sir, I'm having PyCharm.
So you need to convert it into Python. In Python also, I think you can open Jupyter, but I don't know that. We just check it if that option is there.
Yes, sir. Yes, sir. Thank you, sir.
Okay. In Spider, yes, it will not support. So those, as I said, those who are not working on Jupyter or something, the only way is to load here. Again, those who are not using the Jupyter, the way is load here, the file you load here, and then have it on py conversion. Okay. And then again in py you have to fetch the related value. Or yes, or I will do it for you. Just a minute. Can I share it? I don't know. Download. So let me do it for you. So I have this download. Keep it on desktop. So I have the py file. Let me check if I can share with you. If there is an option to share, so all of you can have the py file. Share. So can I share some file here? I want you share content web browser. Let me see. Mute all, manage copy meeting. Share file is there. Where is that file? Wait.
Hello.
Just a minute. It is here only. Right?
Hello, Anup sir, is I audible?
Yes.
Anup sir, I didn't find any download link over there, sir. In the Python Academy PUBG data analysis.py file.
What you said?
I didn't find any Python file.
Where? On GitHub?
ipynb.file.
I just now showed, na? Have you seen the screen when I was showing?
No, I was seeing the screen, but there is no download. There was a download option, but the file it will open in the new tab and showing the code completely.
It will show, and above side download option is also there, na?
Sir, I just clicked on the download option only. It's showing the file in new page.
Okay.
And it's showing the complete code in the new tab. That's all.
Oh, complete code in. Let me check. Okay, let me load this py file first. So those who are not working, I have just downloaded it. Let me check. Written one.
Do we need the GitHub account for downloading it?
No. GitHub account is not required. It is on public domain. So people who you cannot share this file because this file type isn't supported. Okay. So it is not allowing me to share the py file. Okay. Let me share it again. So what you said, it is not allowing to download. If I click on download, okay, it is showing in this format.
Sir, I copied and pasted in a text file and then saved it as a dot .py.
It is an HTML format, so that so it has to be saved and then it will be converted. But there should be a download. Let me check.
Okay.
Just a minute. Download zip is there. So all of you, can you see my screen?
Sir, I am downloading the zip only, sir.
Then in zip, what are the contents you have?
The both files which you presenting in the
So now ipynb file will open if you have a Jupyter. Do you have a Jupyter? Do you have a Jupyter?
No, sir, I don't have Jupyter. Actually,
then it will not open. That's what I am saying. If you have,
You shown me that now we have collab only, sir. We don't have any.
So in collab, as I said, you have to load it.
Yes, I am doing the same.
Once loading is done, you just click on that file. Then it will open.
Okay, sir. Okay. I will do the
Only
same.
loading will not affect. It is your different file and this is a separate section. Got that?
If any requirements is there, then I will ask you, sir.
Okay. So you are able to open that file, or no? That was my question. He is gone. Okay. So what about others? Let me open the chat. It will work on Google Colab, but you have to load that file and click on that file. Okay. Open. Good. Done. Very good. That is how we can derive the testing training data in a given data set. So that is again out of scope for me for this session. Okay. So that is for Dr. R. Gunavati. So that there are different methods like keep, hold and sampling. Okay. Which you can divide the data into. And train test split is also there, which is the simplest. You want us to upload train to data file CSV. Yes, you have to load the CSV file and the second one, the IPNB file. Okay, both has to be done. Those who are not supported means Jupyter, those who don't have Jupyter, anything, Atom, Spider, anything, you convert that through Colab into .py. Okay, that is only the way it will work. Yes, you have to unzip, right? Because it has to be read as a CSV. So we will put a break here. Okay. So because it is supposed to be 1:30 to 2:30 break. Okay. So you do upload onto your Colab. If you are getting any problem, keep it with you. By 2:30 we will start it. So you do let me know if you are facing that problem. Okay. Most of the thing is GitHub is there where you have to download. The download zip option is there. So you have to download it. Those who have the Jupyter can open it. Those who doesn't has to Which screen is shared here? Sachin Deshmukh.
Yes, sir.
Yeah. So you are able to see that, right?
No, I am unable to download the code. I got the downloading of the data set.
No. Downloading of zip file, data set separate link is there. And as I showed, download this one is also there.
Yeah, I'm trying it, sir. I have not got it.
Okay, you try. Who is showing this screen? This is not my screen, or it is my screen? No. I think someone is showing, or only I am able to see that screen. That also I don't know. Too many options are there. But those who can see this screen, you can see on left side the PUBG data analysis IPNB is also there, and train V2 CSV is also there. Yes, you can open in Jupyter also.
Hello, Anup sir.
Yes.
Sir, I have successfully uploaded the file.
Okay.
In Colab.
Okay.
So then I clicked on that IPYNB file.
You can click on that, no? Or you are not able to click on?
I clicked on that, sir, but it doesn't showing anything.
It is not opening. Okay, just a minute. Let me check. Go back. Are you able to see my screen, all of you, or no?
Yes, sir.
My screen is visible. Okay. So if it is not loading, so is there any other option?
Sir, I think this is not your screen, sir. Somebody's screen.
That's what I'm saying. Let me share my screen again. It is sharing someone, Abdul Rahman, that your screen is shared, I think. So how you are able to share the screen? That is, I think anyone can share the screen. Okay, I think now my share.
Stop sharing, sir.
And now my screen is visible, right?
Yes, sir. Yes, sir.
So this one is if not working, is there open new? Okay, open it. Okay, upload notebook is there. So only IPN file you upload from here. And there must be upload option. Choose file, no file. Okay. So what I said is only you keep the CSV file at this place, okay. And IPNB file, it is not directly opening here now. They have changed, I think, something. So you load it from here. You upload it. So it will ask from where to you have to upload. So it will be your drive. If it is not opening your computer, you go to Google Drive. Okay. So from Google Drive also you can open. Both the ways are there. Got the idea? All of you? Prem Kumar, you also got the idea? Means that file, IPNB file only. CSV is at right place. So that need not to be done.
Sir, we have to download CSV file as well.
Download is both the things, CSV and IPNB. And CSV has to be loaded from this side using this button. And IPNB has to be loaded from this side.
Where we can upload CSV file, sir?
From here, na? Upload the session storage.
Sir, I didn't find CSV file in the link which you shared.
See, when you open the GitHub, there is a link. Can you see that? Here is the link for CSV file. You should read that.
It redirects to CSV, sir.
You download it, na?
That is the dataset. Okay, the dataset file is in CSV format. Okay.
Yes. Dataset is in CSV and the code is in IPN. You got the confusion, means see, the data is in CSV format and the analysis or the Python coding is IPNB format.
Okay, got it, sir. I will.
Got it. Okay. Any other who got this confusion? Yes, this may be the confusion. We are not going to have some image or some processing. It is simple CSV file and the code is in IPNB. So those who got that confusion, let it clear. Okay. So we will put a break here. So we will meet again at 2:30 and we will continue this thing. In meanwhile, any problems comes, do have with you and we will discuss it once we come back. Okay. So we will stop at this point. Okay. So should I have to close this or what? Prasad sir? Prasad sir, are you there? I think. Okay. So I will just mute it, let it open. I don't know if it has to be. Okay. So let's meet at 2:30. I will put it here.
So now we will stop at this point. If you have any queries, so you can raise your queries in the next session. So I give thanks to Anup Kelkar sir. The Anup Kelkar sir will going to join in the next session also. So meanwhile, you can take a break, you can frame your queries, and you can put those queries in the next session. So I give thanks to Anup Kelkar sir, and now we can have the break for a lunch, and then we will going to have our next session at 2:30.